All right. So I think we can go ahead and get started now. Hello, everyone. Welcome to Python Fundamentals class, week 1. My name is Siavash, and I'll be the instructor for this series of Python Fundamentals. So this would be our first step through this journey to learn Python fundamentals. And then I believe this is one of the very first courses in the switch up in some switch up programs. So this is gonna get you started with some even more interesting stuff. So hopefully you find the content of this class also exciting. So before I get started with some logistics and some to introduce you the agenda, I wanted to make sure that I get a bit of familiarity with our audience today, the background of our learners. So I'm gonna give you the chance to look at the different tabs on the Zoom because we are using different tabs. So for class activities, and when I ask you some questions like this, I want you to use the chat. And if you want to ask any technical questions, you can put them on Q&A. So for now, please use the chat option and add your name, your location, and if you're currently employed, please add your title and the company that you're working at. So please put them in the chat for now. All right, so I see some answers are popping up here. So let me go through some of them. All right, so actually I see a wide variety of backgrounds. I see we have folks from different industries and also different areas. So I see people from the Bay Area. I see people from Dallas in Texas. We have folks from LA. We have people in Florida. More folks in California. Atlanta, Georgia. I think we have all time zones in US in today's class. Houston, Texas, Redmond, Washington, California, folks from DC, Seattle, Florida, San Francisco, Minneapolis. Cool. Yeah, in Chicago area. Yeah, I guess. We also have folks from Toronto in Canada. Very cool. More folks from Illinois, people from Delaware. Nice. And also I see quite a variety of backgrounds in the class. So I see, let me go back up the list. See we have folks working as solution architect, and I see we have business analysts, we have senior engineers, software. I think we have quite a few software developers in the class, system engineers as well, people in fintech. We have people in IT. We have principal engineers as well. And I see a variety of companies. I see Amazon. I see Broadcom, Meta. I see people from Microsoft, again, principal, software engineer. We have technology architect, budget analysts, data integration architect. We also have data engineers in the class. We have people from. Um, we also have full stack developers. Um, database analysts. We have so other software engineers, and also see Walmart. I see Department of Transportation. Again, folks from IT sector. Very cool. All right, so yeah, thank you everyone. So this is great. All right. So yeah, I mean, thank you all for participating in the questionnaire in the beginning of the class. So this is very helpful for me to get a feel for the background of the learners in this class. But as you can also see, we have people from all sorts of backgrounds and different, perspectives, probably. So I think the goal um, of taking this class could be different from the variety that you see. So I think we have folks in the class who may be entry level to Python, but we also have folks in the class who actually probably know the principles of programming better than me, or higher levels. So I think the point of this class in the beginning of this switch up program is mainly about understanding the Python fundamentals, the basics of programming, how you write simple code, and starting to build up on top of that in the later classes, and also as you move through, basically in your journey in machine learning and data science. So that makes it a little bit tricky teaching this class, because I want to make sure that this is a class for everyone. So we are going to start from the very basics, input and output, how to get input from the user, what are variables, this kind of stuff. So I'm going to assume that we have minimal background in both Python and programming this class. So that's why I usually let everyone know that if you feel like, I'm going to show you the agenda in a bit, and if you feel like that this is the level is not the right level for you, feel free to skip this one and then join the next class. And the way it works is that the first two classes is all about Python fundamentals, and the third class as well. But we're going to learn about how to write a class and object-oriented programming in Python. So that may be of interest to some of you. And then in the fourth week, in the last week of this class, we're going to learn about Python for machine learning, which is kind of a segue from what we learned in this series, and then what you're going to learn after that in data science, feature engineering, preprocessing, those kind of topics. So feel free to attend these classes or skip if you find the material not the right fit. But hopefully I'm going to go over quite a few functions in this class, and in our Thursday sessions we're going to learn more about how to solve problems in Python. So hopefully that's useful, even if you're coming from another programming language. All right, so about myself, my name is Siavash. I'm a Python and machine learning instructor at Interview Kickstart. So I got my PhD in aeronautics and astronautics from University of Washington in Seattle. So after that, I got my first job as a machine learning scientist at Microsoft, where I was working on optimizing campaigns. There's a big initiative at Microsoft about campaigning for different products, and we were trying to optimize the content of those campaigns on different surfaces at the intersection of customer facing products. So what I was doing there was basically working on a reinforcement learning based algorithm to further optimize those content delivery. So that reinforcement learning background was coming from my PhD, where I was working on multi-agent systems, using the data from those systems to basically control a part of your network, let's say a network of robotics, and then expand this control throughout your multi-agent system. So that's where my background lies. And then after a couple of years, I recently joined Uber as a machine learning engineer. And here at Uber is a little bit different. What I do is basically I'm on the dynamic pricing for riders, and we use machine learning algorithms to basically address this trade-off between customer satisfaction and the gross bookings at Uber. So so it's basically part of the algorithmic pricing initiative at Uber. So currently I live in San Jose, California. And I'd be happy to connect with all of you. So I'm usually ask everyone, let's get connected, and I'd be happy to help if you are in any of the steps in your interview, and if I can be of any help, I'd be glad to help. All right, a couple announcements before getting into the agenda. So interact with your instructors. So with me and our TA, we have a TA for today's class. So this class is usually set up for 4 to 5 hours. And you will see that we have a lot of topics to cover. So for me, it's not really feasible to stop at any point in the class, because we're going to make sure that we cover all the topics by the end of that 4 to 5 hours. But after each topic, I'm going to pause. I'm going to go through the questions on Q&A. I'm going to make sure there are no unanswered questions. If I don't know the answers to any of the questions, which might happen for sure, then I'll actually take time during our breaks in the class or after the class to go and look for the answers to those questions. And if you want our TA to address your question during the lecture that I'm not pausing, then you can put your question in the Q&A, not the chat, in the Q&A. And then feel free to raise your hand after each topic. When I pause, we also have time for one or two, more interactive discussions. But also, I highly encourage you to attend the Thursday sessions for assignment review, where we have even more time for further discussions, problem-solving techniques, and all sorts of that kind. So please go over those assignments, and you'll see we have some multiple choice questions and some other coding problems. It's very similar to the Lead Code platform, what we have in assignment review for the first 2 weeks. So I highly encourage you that if you haven't seen that, please go over those questions and come prepared for the Thursday class. And then use your resources. So I just shared in the chat. Let me make sure I did that. I think I did. So in the chat, in the beginning of the class, I shared the link to the slides that you see on my screen. So there will be changes to the slides that you see today and the slides that you probably have access to from the past. That's because I made some changes after teaching this class for a couple years now. I realized that there is a need for some improvements to these slides, and also the code. So we're gonna cover this notebook today. So I also put the raw format of this notebook, the link for you. Feel free to take a look, and I highly encourage you to code along. So try these things as we go through them. So it seems like the links are not working. So if you go to your up-level profile and then click on the link for today's class, there should be some materials that are uploaded by me. and you can actually get the link to the Google Drives for that. But just to make sure, I would also share that with everyone again. So I put the links again for everyone on the chat. So take a look and let me know if you got access or not. So if you don't have access, then maybe you can reach out to operations on this one, because I don't have any other idea how I can share these with you. But okay, so I think we went through these announcements. Just to remind you, this class is going to be about Python basics and fundamentals. If you're looking for more advanced topics like data structure and algorithms for interviews, or other topics, please take a look at the curriculum. There are classes for all sorts of topics that you can find. But this class is going to be about this list today. So we have 3 parts in today's class, separated with 2 breaks. So in the first part, we're going to go over some basic concepts and introduction to what is Python and why we are learning it. And then what are variables, what are data types, what does typecasting mean, and how can we use it in Python? And then what are operators, including arithmetic, logical, and comparison operators. There are more operators, which we're going to learn later in the class. Then we have a 10-minute break. And after that, we're going to learn how we can write conditional statements in Python, and how we can write loops, for loops and while loops, and how we can write a function in Python. And then in the last section of the class, we're going to start with more advanced data structures, which are particular to Python. I mean, not particular to Python, but the way they're defined and the way they're basically implemented is different in Python, which makes it kind of special or more advanced. So we're going to learn about lists and strings in this class, and then we're going to continue learning about those data structures in the next class, to learn about tuples, sets, and dictionaries. All right. So, and the last thing is some of the suggested lead code problems is this list for today's class. So after this class, you should be able to come up with some solution to these problems, not a very optimized solution. So we are not looking for a very efficient, memory time complexity, highly optimized. We're not looking for that in this class. We're looking for having some solution to this list of problems. So if you haven't heard about LeetCode, it's a website that people use for coding practice. It has like quiz type problems for you to solve and assess your data structure and algorithms knowledge. So these questions can be actually tricky and not trivial questions if you want to find very optimized solutions for them. But in this class, we're just trying to get to some, basic solution, right? Some foundation, so that we can build up on. On Thursday class, for some of these problems, I will show you how to make it more optimized. But if we go over any of these questions in the class, it's not going to be optimized. It's going to be just a working solution. And usually we don't get the chance to go over all these problems in the class, but I have them on the slides and also the notebook for your practice. So if you don't get the chance to do this in the class, I want you to take a stab at it at home, and then we can actually we are gonna go over those on Thursday class, and you can ask questions and see if there was any issues with your solution. Okay, so before we get started with basic concepts, I see there are a couple questions in the Q&A, and I think there is now access to the links that I shared, which is great. But I also see a couple questions. So the first one is, hi, is Fireflies needed? I see the link on the chat. I installed it and it was too intrusive, so remove it. So So honestly, Fireflies is very new. Um, I've never tried it on Zoom here at Interview Kickstart, so I think that is a new feature added. So I haven't tried it. Um, you can ask operations about if you have any issues. Please ask operations, but you can also ask your questions on the Q&A. I assume that we have a TA in today's class, but if not, I'm gonna go over questions anyway after each topic. So feel free to try it out. I haven't, but yeah, I'm assuming that it's gonna be our AI agent for questions in the class. But yeah, I haven't tried it yet because it's very new. The next question is, which online editor would you recommend to practice Python? Could be free or paid. So actually, I have a slide on that. Let me go over your question when we get there in 2 slides. Okay. All right. Let's go here. Let me also go camera. All right. So first of all, let's begin with why Python. So why are we learning Python? So first of all, as a programming language, if we don't think about the applications and use cases for now, we can just say that it's so simple, highly readable, and very consistent when you compare it to some other programming languages. Um, so you will see that as part of the syntax, we're going to use a lot of English words. So I usually say it's as close as it gets to our natural language, right? But from another point of view, it has a vast ecosystem and ready-to-use frameworks. So in the past decade, there has been so much improvement to especially data science and machine learning applications that now we can find a ton of open source, frameworks, libraries, and also a huge community, right? That you can actually connect with, use their code, and build on top of what already exists, which is now quite large. So this is not particular to machine learning and data science. Probably you're sitting in this class because you're interested one way or another in data science applications, probably, but that is not the case. Now you can see there are tons of open source libraries out there for a ton of other tasks in engineering, in finance, in economy, and the applications are now everywhere. So, but if you particularly look at machine learning and data science, there are tons of very popular libraries now that are actually the default. Now, usually when you install Python through through any sort of package or software, you realize that it comes with some already installed libraries like NumPy or Matplotlib. So these are some of the libraries that are now a part of the language, kind of, because they're so popular and so widely used. And when you think about cloud-based APIs and working with big data or any advancements in these areas, for example, now you have other tools like PySpark. So it's the basically the API of Python for Spark, which is used for distributed uh, data processing for big data applications, or PyTorch or TensorFlow, which are basically deep learning wrappers for Python, which are implemented by built by Meta and Google. So these are all based on Python, right? So these are the main use cases are in Python. and you have access to most of their features and capabilities through Python, because that's the go-to language for these applications. And as I said, the applications is not just for machine learning, AI, and in the industry. It spans sciences and engineering, and not just in industry but also in academia. So I remember I was using Python a few years back. I think 6-7 years ago, when I was working on optimization and different algorithms. So it was open source, and I could find a lot of libraries, and yeah, we didn't need to basically purchase any subscriptions for that as well. So if you want to learn more about more reasons on why Python and why you should learn Python, I put this link here. Feel free to take a look. Uh, Now about installing Python. So I really hope that everyone has figured out the installation by now. That's kind of a prerequisite to this class. That will be great if you have it already working, because you're gonna code in this class actively, and we have lots of syntax to cover together. But if you haven't, feel free to take a look at this, the downloads tab on Python website, or you can take a look at Anaconda, which is a website to install Python and some other useful packages, including PyCharm, or Jupyter Notebook or Spider. So now, getting back to the question on what is the recommendation on a good Python editor. So there is no preference here. So basically, it's just a personal preference on which editor or notebook you're going to use. So what I would say is, you can use either. You can use either an IDE or an editor, basically, where you have actually your code written on a script, and you run the full script and get your results, right? So for editors, you can use PyCharm, or you can use Visual Studio Code, or any other editor of your choice. I cannot really think of much. They are different, but it's not like we will see the difference through this through the items in this class, because we don't need much advanced options for each. We're just trying to run some basic Python code. But I have used both, and they are both great. So currently I use VS Code in my day-to-day job. So previously I was using PyCharm for my research. So both of them are great and have really good features that enables lots of other dependencies work on Python. But in today's class, I'm using a notebook, right? So I'm using Jupyter Notebook to actually run code and actually put notes for you on the notebook. The reason I prefer a notebook for the class is because it's more interactive. I can have notes on it. I can run these cells one by one, and actually I can add or remove code very easily and wherever I want here. So it's more interactive. So that's why I'm using a notebook. And for notebooks, feel free to use Jupyter Notebook or Google Colab, right? So both work fine. Actually, Google Colab is built on top of Jupyter Notebook, so it shouldn't be that much different. Maybe some short keys and some operations. Maybe those are a little bit different, but the overall look and the overall functionality shouldn't really change from Jupyter Notebook to Google Colab. All right. So if you're not able to click on the link, so let me actually put these links for you in the chat. So you should actually be, if you have the PDF, that should be accessible, but I'm gonna put these links one by one in the chat for you right now. All right, so I put all the links for you in the chat. Feel free to take a look. But let's continue, and then actually we're gonna learn some basic syntax now. So the first two ones is printing and getting input from the user, right? So those are probably the main two functions we usually learn when we're gonna learn a new programming language. So the first one is printing, to actually show something on the display to the user or in the output. So this function prints text, it prints numbers, results of expressions, and basically everything. We have some other functions in Python if you want to log information in the output. So that would be a topic for later. So for now, if you want to show some text, number, or some expression results, you can use the print function. So this function has this, basically what it does is it prints these things and then adds a new line character at the end. Right? You can actually avoid that by some options in the print function, but I'll show you that on the code as well. But your text can also be modified with some special characters. So you have some special characters, and this, when you have this backslash, basically you have one of those special characters. If you want to add a new line, a tab, or if you want to actually have a backslash in your text, or single quote or double quote, etc. So before we go to the next one, as we can see, this function has a name. The name is print, and as you can see, it's actually the English word print. And then we have these parentheses, which shows that we actually have a function in Python. So now, when you put this in your code, you're calling this function. And then if there's an input you want to give to the function, you'll put those input inside these parentheses. We call those inputs parameters or arguments as well. So we learn more about functions in the second part of today's class. But for now, just keep in mind, this is how a function would look like. Now, in the next example, the name of the function changes, but we still have those parentheses. So the input function gets input from the user. It collects user input as a string. Okay, so we haven't learned about variables and what we mean by string, but it's basically inevitable. So we have to go back and forth. So string is a data type to display text mainly, and we're going to learn more on different functions in Python, which enables some some stuff that we can basically do to text, right? So like capitalization, uppercasing, lowercasing, partitioning, these kind of things. But for now, let's just basically just understand that we can collect the user input as a string. If you want to get the user input as some other types, like a number or some sort of a flag, like true or false, then you basically just need to change this or convert this data type to some other form. So we call that typecasting. We're going to learn more about all of these things. So here's how the syntax looks like. Besides writing the input as the name of the function, inside the parentheses, we got to have a prompt. This is optional. So the prompt is optional. But if there's no prompt, then the user probably wouldn't know what is asked for, right? So what they have to provide as the input. So the prompt is optional, and it displays a message to the user that, this is what we want from you. This is the input. and then the user enters that. So two more concepts before we go to the notebook. First is commenting. So we have the concept of commenting in all programming languages. So in Python, we have single line and multi-line comments. So comments are actually code in between your main code, which are not executed, and it's just there as hints, like what this line of code does, or what this function does, or later when we learn how to write a class, what's the purpose of this class, and what are different methods and attributes of this class. So a single line comment in Python starts with the hashtag or the pound. And if you want to do it very quickly, you can use the control plus slash operation. So if you're on a Mac, you should try command and slash. So this will turn that code into a single line comment. Or if you highlight a few lines in your code and basically press these two, then you'll see that all those lines will be commented out. If you want to do multi-line comments, for example, explaining within a doc string that what your function does, you can enclose all your lines between triple quotes. Okay, you can use either triple single quotes or triple double quotes. It will make all your codes into a string, which is not assigned to any variable, and that becomes sort of a multi-line comment. Okay. And then there are some principles that we are going to follow. I'm going to mention them here, but we're going to see that in practice through the code. So one is the indentation for code blocks. So when we get inside the code block, we have to actually make sure the interpreter or the language, the programming language, understands that we have actually started the code block, right? So we use indentation to do that in Python. So indentation is basically some white spaces in the beginning of the line of each line of code, which shows that we're actually inside a new block. But this is different from if you're coming from other programming languages, probably you don't need that white space. You can actually use braces. But indentation is mandatory in Python, but the number of white spaces is not. That is optional. You can choose any number. Usually, we have a default of a tab for those white spaces, but it is optional. You can use any number of white spaces in the beginning of the code block. So we're going to see examples of this when we learn about conditional statements or for loops, or when you want to write a function. Those are all code blocks that we're going to learn. The other concept is dynamic data typing, which is basically when you define a variable in Python, you don't need to specify what is the data type there. So maybe in other languages you have seen that you need to specify that this is a string, this is an integer, this is a Boolean. But in Python, that will be interpreted automatically under the hood. So you don't need to specify that. But in the meantime, you need to make sure you understand what's happening there, so that when there is an overwriting of a variable or anything in that sort, then you know what's happening. It's actually dynamic data typing behind the scenes. So we're going to learn more about these things soon. But now, before we get to formal definition of variables and data types and those things, let's familiarize ourselves with the notebook that we have for today's class. All right. So feel free, if you have access, feel free to open the notebook and try these things while I'm doing it. So that will be very helpful and a much better learning experience. So we mentioned about commenting. So first of all, this is the view of the notebook we're gonna work on for the next few weeks. Um, so actually, each of these are cells that I write my code or my comments on. You can actually change a cell from a code into a markdown and start writing uh, these kind of comments there. So if I turn it into a markdown, now I can actually write a note here, right? And when I run this, it becomes a note, right? So that's how I'm how I have prepared this notebook so that I have some comments for you and some code. Now, inside the code, I'm starting with some comments, right? So I'm gonna put a comment here. This is a single line comment. Comments are not executed. If I run this cell, if I click on run, nothing happens, right? So this has run. So this is saying this is my second cell in order that is running. And when I run it, it becomes now 3, but nothing happens below that, right? So usually when you write something meaningful, for example, print, you know, let's say interview kickstart, then it will print something for you, right? But when you execute a comment, nothing happens. So that's the nature of a comment. It will not execute. It's just a hint in your code. And then the other thing is the color coding, right? So you see that the color coding becomes sort of neutral, and all of the characters have the same color. But this is not the case for a normal Python syntax. For example, for I in range, um, you know, 5, and then I'm gonna write print I plus 1. So this is a syntax that we're gonna learn later today when we learn about for loops. But as you can see, color coding is much different from what we see here on this commented line, right? So we have all sorts of colors and all sorts of font types, right? So okay, so that's one other thing about comments. The other thing is you can have multiple of these in your code. I mean, it is highly encouraged to actually put comments in your code, because if someone is going to read your code or for your own later reference, it's much helpful to know what's happening in which part of your code. Sometimes code bases could actually extend to thousands of lines of codes, and if you don't have any comments, then it would be so hard to find where to find what and what's the functionality of a particular snippet of your code. So that's why it's highly recommended to have hints or these kind of comments anywhere needed in your code. So a couple helpful short keys in Jupyter Notebook if you're using Jupyter Notebook. So I told you about this. If you press on command, then it could be command or control. And slash, then you'll see what happens. So your code is commented or uncommented, right? And if I pick all the lines of choice and do the same thing, you'll see that all of those lines will be commented or uncommented. And then if you want to run this cell without pressing on the run button here every single time, you can just simply press on command plus return, right? So command and plus return is running this cell without me going back and forth and press on that run button. And then the last note about commenting is you can have multiple lines of comments if you use triple quotes, could be double quotes or single quotes, and then whatever goes inside will actually become a comment, right? So let me actually separate these two. So let me put this here. Okay, so what happens here is, and you see that the color is also different, right? So the color coding is different from a single line comment to a multi-line comment. So the reason to that is the nature of these objects are different. So this now becomes a string. So whenever you put something inside triple quotes or inside triple double quotes, you're basically defining a string, right? Now, if I run this cell, you see that something is different, right? So something has actually been executed. And you see that result out there in the output. And the reason is we are actually defining a string here, but because we are not assigning that to any variable, it will be gone. So it basically serves as a comment. But in Jupyter Notebook, the last object that you put on the cell will be printed out for convenience, right? So it will be very convenient if you have multiple lines of code. And for example, I'm gonna say A is 2, I don't know, B is 3. And then what I'm gonna see quickly, I'm gonna check what is A plus B. And then in Jupyter Notebook, the last thing that you put on the cell is gonna be printed out without you writing print of A plus B. So both work fine, right? But you can, to make things much quicker and much more convenient, you can just forget about, it's fine if you forget about writing the print, and we will show you the output to you. So this is what's happening here. So that's why you're seeing this output right after, executing this line. And then same thing for this one. So you can have another one, and then when I run this cell, you see this output, but basically nothing is happening in your code because you're not using the string at any point in your code. Okay, so I have some notes, throughout this notebook for you. Feel free to take a look at those. We're not going to cover everything in the class because of time restrictions. But one thing I want to point out here is that you may ask, why do we need these triple quotes when we have this single line commenting? Why can't we just have multiple of these single lines instead of this one multi-line? So that is a valid question, and you can actually do that. That there's no issue with it. But sometimes there are coding styles and some conventions that through time, people have actually come to an agreement that probably this is the best way to do it. And now, when someone looks at this kind of syntax, they know that this is probably a duck string trying to give us some information about a function or a class. And when people look at something like this, they know that probably this is a comment about one single line of my code. Or you can actually have a line of code. For example, I'm going to write, let's do a, and then at the end of this line, I'm going to write assigning value to my variable, right? So you can actually put a comment at the end of your code, which gives a direct information about what you're doing on this line, which could be very helpful. Okay, so basically, this is a convention that people use these kind of commenting for functions and classes, and single line commenting for in between lines of code. Okay. All right. So this is mainly about that and what's the difference between these things. Feel free to take a look. Now we're gonna go to the next one, which is the print function. Okay, so the print function, basically you write print, and inside this parentheses is what you want to print. So here I'm using double quotes to create a string. So this is called a string, is one of the main or primitive data types that we're going to learn on the next topic. It's basically a text or textual data, which is placed or enclosed with these double quotes. So when I run this cell, you'll see that string in the output. So that's what we're trying to print. Quick note here, if you're trying to actually have double quotes in your string, so let's say you want to enclose this hello with double quotes. So if I put double quotes, then something is off here. And the reason is these two double quotes and this one and this last one, they're all paired, right? So that's why these two are defining two different strings, but what comes between them is not. So it's not part of that string. So in that case, you'll get an error. You'll get a syntax error saying that this is an invalid syntax, and perhaps you forgot a comma or something, right? So to make sure that you can add these double quotes in your output, then you can use single quotes to define your string. And your double quotes will go inside that string now. Okay. So that is one way, and maybe the other way is basically to just simply use a special character here, right? So we can make these special characters to have those double quotes shown in the output. Okay, so this is what we have in the next example. And then if you want to have two lines of prints in the output, then you can have two prints, and each one comes with a new line character. So if I run this, you'll see that after printing the first one, we're going to go to the next line. That's because every print function comes with a new line by default at the end. Okay, so we learn here how we can actually override that ending. But before that, let's see how we can actually put a space here between these two lines. If you want to do that, then you can simply put another print in between them, right? So if you put another print, it basically goes to the next line here, and then nothing will be printed here, just goes to the next line, and then the last line will be printed, okay, like this. Okay, so that's what the example here that we have. Another way to do that, actually, to add that new line, is to add a new line special character at the end of the first line, right? So we learned that we have special characters. \n is for new line. If you add that, you get an additional new line on top of what print function provides, and it will give you a new line. So if you add one more, you'll get two new lines. Okay. Okay. So more on special characters. We have a few more here. So I'm writing my string right here, but in between those words, I have a \n. And then after the next few characters, I have two backslashes. And then here I have a \t. So let's see what happens here. So a \n moves us from right after this character, the exclamation mark, to the next line. And then this backslash or double backslash is going to give us this backslash here. So this is basically the use case where you want to actually see a backslash in your string, but because one single backslash is reserved for special characters, we're going to use two to get this in the output. And then \t is basically showing us this white space here, right? So if you want to get a standardized white space in your string, then you can use \t. All right. So the next thing is adding more options to our print. So here we have the print option, and we're going to print this word, hello. And then we have some options for the print. So actually here I'm putting this notebook hint for you. If you press on Shift and Tab, at the same time when you're inside a function in Python on Jupyter Notebook, then you'll get this docstring hint, right? Which shows you what are some of the options that you have. And you can take a look at the documentation and see what each of these does. Yeah, you can try them out. So we're gonna learn about a couple of them here, but for sure we don't have enough time to go over all the options of all the functions. So feel free to take a look at the other options at your own. But here, instead of a new line, a special character, I'm actually overriding what I want to happen after I print this. I don't want it to go to the next line. I'm going to stay on the same line with a white space, right? So in that case, when I run this cell, instead of going to the next line, I'm going to stay on the same line with a white space that I defined right here, and then print the next word. Okay, so by default, this is a \n, but you can change that. Now you can actually do, I want it to end like this, or I want it to end with a \t, or I want it to end with a dash. Whatever, I mean, you choose, you can actually put right here. Now, print is a function that can get multiple variables as input. So here I want to print this string, and then right after that, with a white space, I'm going to print this number, and then another string, and then another number, right? So you can see that these multiple objects are separated by these commas. So in that case, you will print all of them in one single line, but there will be a white space between those, right? So there's a white space separating those. And this is called a string concatenation. So we have multiple values, and Python under the hood converts all of these things to a string, and then it will concatenate those strings one by one with the given order. Okay. Now, what if you want to separate these things with some delimiter, right? So let's say I don't want a white space between the two. I want a comma, or I want a dash. So that's how you can actually do what you can do with this separator option. So here we had the end setting. Now we also have another setting called separator. If I have multiple inputs that I'm gonna print side by side, but not with the white space in between, but with a separator, I can actually define that here. Okay, so this separator could also be dash. Okay, so I'm going to use comma and a white space here. And the last example for print is dynamic printing using f strings. So let's say I have some variable that I know the value of. So this is a syntax we're going to learn on the next topic. But let's say we have this variable and we know the value. And here we have a string. And we're going to kind of add that value. But this value is variable, right? So it could change. The value of this variable could change later in the code. So we're going to actually put the variable name, but I put an F before my string to actually, which indicates that we have an F string. An F string is where you can format your string. So my name is, and then inside this curly brackets, I'm going to put the name of the variable instead of the string directly. Okay, so now if I run this, it will show this string with the name of this variable that's defined here. But now if I change this name to something else, it will swap those names, right? So now you can actually have one variable, but you can actually have different values to that variable. So there's another way to actually do this. So if I comment this line out, you may also see this syntax. There's no F. And then here this bracket is empty, but at the end there is dot format, which is another Python function, dot format, and inside format you'll have my name, right? So this is also another syntax you may see out there. But usually people use the f strings if they want to have if they want to format their strings with dynamic variable values. All right, and then the last thing here is input function. So let's see a few examples for input function. So I mean, the prompt inside the input is optional. So basically, this is a valid syntax. If I run this cell, it's requesting an input. I can just put ABC123, and that's it. Nothing happens, right? But this is very vague because the user doesn't know what the input is going to be, really. So here, I'm actually adding a prompt saying enter your name. And now when you run this one, you know actually what is the question, what is the prompt, right? So I can add my name here. Or you can actually ask for a number, right? So enter your number, and I can just put 23. But remember that even the number is stored as a string, right? So later, if you want to use this number in some arithmetic operations, you have to convert it into a number. You have to convert it into an integer or float. We're going to see that in a bit. So some use cases, basically these are some sneak peek into what we're going to learn later in this class. But if you want to get two inputs from the user, you can do that. You can ask them to separate them by space, for example, 2 and 3. And using the split function, we can split the string and then get those as two independent input from the user. Or you can get passwords from the user using some other library in Python. Get pass is a library, for example, you can use for that. If you want to collect the password, and then you see that your password will be hidden, or you can actually reveal it. So this is just something quickly showing you as a demo. It's not the main topic here, but these are some sorts of inputting in Python that you can use. Okay, so we're going to learn more about input and how to typecast it and all sorts of things later. But this was just showing you how you can use these functions for now as the basic syntax. So before going to the next topic, which is variables and data types, I want to pause here for a couple minutes to make sure there are no questions and all questions are addressed. So, okay. Let's see. So I think there was something in the chat that about the Google Drive posted as link to code that when I click nothing happens. Out of 2 Google Drive links, I'm able to click on one. Oh, I see. So I think there's a question that these codes, the link I provided actually gives you a link to the IPython notebook. So it's a IPyNB file. You have to install Jupyter Notebook. Then you have to run Jupyter Notebook on your, on your device. And then inside that, you have to find, this file, right? So if you go to the terminal or maybe I should use another terminal. Maybe I can use a new window. If you go to the terminal, so I'm on a Mac, you can try command prompt on Windows. And if you have Jupyter Notebook installed, then you have to write Jupyter space notebook. And then this will open up Jupyter Notebook for you. And then you'll see a directory. You go find the file. So you have to download that link and download the file from the link. And then you find that file within your Jupyter Notebook directory. So then you can actually open that file in a Jupyter Notebook. Okay. And then I see that there's still issues with accessing the link. So please reach out to operations on that. It should be available on your up-level profile as well. If you go to the link to this class on the shared materials with learners, you should be able to see some stuff shared from me, but yeah, so I'm gonna actually share those with the operations maybe after the class, and they can share with you. But I think some folks in the class had access. So let me try this out again. Yeah, I think so. For me, they're both clickable. I tried again. So see if you can get access to those. Let me actually go over the Q&A. Subra, you have a question? Feel free to unmute and ask your question.
Hey, Shivesh, yeah, that's why I'm trying to click on the link to code, but it's not clickable at all. Yeah, I know like what you said, we need to import it in the Jupyter notebook in order to use it, but like first I need to have the access, right? When I'm trying to click on that link, nothing happens.
So I just shared the link again in the chat. Can you see, is it still not clickable?
Click that. Yeah, now I'm able to. This the second time what you shared. I'm able to. Let me download this one. Yeah, I'm
Okay.
able to download. So, do you want me to
Okay.
open this?
Yes.
Either
So if
Phantom or
you, sorry.
yeah, either Phantom or Jupyter. Which one is recommended?
So you can use Jupyter Notebook. Yeah, you can feel free. I mean, if you already have Google Colab set up,
Yeah,
you can use
everything
the
for
web
us
browser.
actually. Yeah. Mhm.
Okay, so
Yeah.
then feel free to use Google Colab. So we can open this file inside Google Colab, and then you should see something similar to what we have here. It is a little bit different, the interface, but that should be good actually.
Yeah. Thank you.
Yeah, yeah. Yeah, thanks for letting me know. Hopefully, this one works now. I see there's another hand raised. Mojgan, please go ahead.
Sorry, I apologize. No, it wasn't.
Oh, it's all good?
Yes, thank you.
All right, no worries. All right. Let's see. I see there are some questions on Q&A from where to import this code. Okay, so I think we answered this one. How does the shortcut work? Command plus return. So all of this code, when I'm trying to run, I press on command and return at the same time. If you're on a Windows based machine, you can press on control and enter, and then it will run this code for you automatically. I think it's the same in Google Colab. It may be different. I don't remember the all the shortcut keys there, but there's a list of instructions to that. You can take a look. So what is a Jupyter Notebook? Is it similar to executable? So Jupyter Notebook is basically this what you see on my screen, an interface, is a software that comes with Anaconda, and it's basically a convenient way to run code in Python. It's pretty similar to Google Colab, and yeah. So yeah, I mean, if you have question about the details of it, I'd be happy to answer that. But yeah, let's go to the next question. Could you please reshare the link? I reshared that, and then I mean, to restart, I have an alert that won't stop, and nothing I've located seems to turn it off. I need to restart. I have an alert that won't stop and nothing I've located seems to turn it off. So I'm not sure about this one. If you can give us more context, Jeffrey, I'd be happy to look into that. Okay, so I see another question. Actually, I'm gonna let our TA go over these questions because we want to make sure we're on time. Abhinav, you have a question?
Yes, thank you very much, Siavash. My question was with regards to the Jupyter notebook itself. What is it, and if we could explain a little bit about on a first principles basis as to what is the practical usage. I understand it is like right now we are using it and seeing it in the flow, but in practicality, is it more useful around moving collaboration, sharing work, or is it just mostly uh, like a GitHub substitute of locally sharing your work more locally rather than
Yeah.
through yeah.
Exactly. So that's a very good question. And so Jupyter Notebook is usually not used for production code. It's not used for as a replacement of the code base. It's usually used for some dev work, trying things out, and also for analysis. So the nice thing about Notebook is, let's say you want to, you have some main code base runs, which could be thousands or millions of lines of code, and then you get some tables as a result, and then you want to put your table somewhere here, and then you're going to do some visualization, get some stats, and understand better what's happening in your tables. Then a Jupyter notebook is the right way to go, because what it gives you is instant changes to any of these cells, and you can run this cell very quickly and understand what's happening there without needing to run your code base from scratch. You don't need any unit test, integration test, anything. So you can just simply run each part a simple code snippet just to try it out. So it's mainly for dev work, and if you want to test something or try it out, you'll use Jupyter Notebook. But code base, which actually runs code for production, is for that purpose, a notebook is not basically the right thing. So you need a script in your code base, and then those scripts will be run or rerun on a weekly, monthly basis, and that will be what your code base looks like. Does that answer the question, Abhinav?
Yes, it does. One very quick follow up. Are you able to run how are the cells defined? Can multiple lines of code be a single cell, or
Yes.
how do you determine the granularity here?
So each of these cells are independent, right? So when you run this cell, then only the lines in that particular cell are executed. But if you define a variable, then that will be actually part of the memory. So if I, for example, define a as my variable here, then this a will be transitioned to other cells if you can actually see the value of a in the other cell, right? But the run of this cell is independent from the run here. So if I run this cell, I'm not defining a here, but I'm using the value of that, right? So we have dependent cells, but the memory will be shared.
So if you 49, you would still get the right answer. The value is 2 because it's 48.
Yes. If you run this, then you actually the memory will be shared with the other cell. So if you run another one, you'll get those values that defined in the other cell.
Got it. Okay. Thank you.
All right. So I see a couple more questions. Sridhar, please go ahead.
Hi, I have zero basic knowledge of Python, so please bear with me if there are two basic questions.
No worries.
Well, one thing is, as I asked in the chat, like, can we loop the functions?
So sorry, what do you mean by looping the functions? Can you elaborate on that?
If you see my message in the Q&A, it says, can we do like print of, sum of, input of, something like that? Can we do like that?
Yes, definitely. Yeah, you can do that. Yeah, you
Okay.
can have. So we will learn about sum later, but you actually can have sum of 1, 2, 3, and then you're gonna print that. You can
Yeah.
definitely do these kind of things, right?
Okay, so we can do multiple functions into that loop. Okay. Okay, that is one question. And the second question is, a while ago you mentioned like this is Jupyter Notebook, right? So is this in the real world like a work? What kind of environment they use if it is not the notebook to run their Python programs?
So for those use cases, actually you can use editors like Visual Studio Code or PyCharm, and they will be directly connected to if you're using, for example, a compute cluster or anything else. Those scripts, there are actually instructions on how to get those connected to your compute, and then there will be an automated run of those scripts. So you don't use Jupyter Notebook in those kind of applications.
So it is technically like those environments are connected to their servers where the data is located.
Exactly.
Okay. Thank you. That is all for now.
Thank you, Sridhar. All right, so I'm gonna get two more questions and then I'm gonna move on. Cynthia, please go ahead.
Hello.
Hi, Cynthia.
Hi. So I have a question for how we can use a Visual Studio with the Python.
So how are we gonna use Visual Studio?
Yes, I want to know how we can use the Visual Studio with the Python.
So you have you installed the VS Code?
Um, I installed actually for the SSIS and SSR reporting servers.
Okay, so actually, let me share a link with you. So we don't have the time today to go over the exact steps of how to make Python work in VS Code, but I can share a link with you. So let me, in the first break time, I will share a link on the chat, which shows you the exact steps on how to make Python work on Visual Studio Code. Okay?
Okay, thank you so much.
No worries. So let me actually write the code, Python. Okay, the last question here, Vijita, please go ahead.
Hi. So you mentioned that we use Jupyter for development and analysis, and once the analysis is done, and we know we want to deploy the code, and we, let's say, using PyCharm to deploy the editor, right? So how does it sync back? Do we do manual syncing of our code, that the new code that we wrote up in the Jupyter notebook over there in the editor, or is there a automatic sync mechanism?
So usually that's not the case. Usually the code that you have on Jupyter Notebook is totally independent as an independent entity, and you just run your notebook on the side. Usually it's the other way around. Usually the code that you have on your code base, you copy some part of it in your Jupyter Notebook. But mainly what you have on Jupyter Notebook is just for dev purposes, and if you want to actually sync that with your code base, you basically bring on some snippets of the code to your code base.
So it's
Right?
it's a manual copy, then you're saying, right? Then we take that
Yeah,
whatever.
exactly.
Yeah. Okay.
Exactly. Yeah. It's usually considered as an independent kind of work stream. So
Okay.
yeah.
Thank you.
Thanks for the question. All right. So and then the last thing I wanted to go over was a couple comments in the on the Q&A. So it seems like Google Colab has worked with this code. So can I do a comment at the end of a coded line? The answer is yes. You can add your comment anywhere in the line of your code, either at the end of the line or before or after that line of code. So anywhere is fine. And then about the F string, which one is more preferred, F string or concatenation? Depends on your use case. You can use a concatenation when you have multiple input, but then for different variables, you can use formatting or F string. So actually, let's wait for arithmetic operations, and you're going to see more examples of that as well. All right, so let's move on to the second part, variables, data types, and typecasting. Okay, so what are variables? Variables are containers to store values for later use in the code. So sometimes you want to define a variable. It contains the value of your variable, but you want to use it multiple times in your code. So it's not efficient to each time define a variable for that. So you define one variable, and as you saw earlier in one of our examples, that variable would be identified throughout the code. So in Python, as we mentioned, as one of the principles, we have dynamic declaration, which means that you don't need to declare the data type in advance. Python will interpret that. And the name of the variable can be a combination of letters, digits, and underscores. Okay, so keep this in mind. We have letters, digits, and underscores only. And a variable name cannot start with a digit. Right? So that is one caveat here. You can never start a variable name with a digit because that is reserved for arithmetic operations. If you start a line of code with a digit, then Python expects some arithmetic operation like adding, subtracting, something like that. So then we have these containers, we have the variables, and what goes inside is basically the data that you want to store, and those data have different types. So data types are actually the type that defines the nature of those values, right? So you specify the type of the value, and then from that, the allowed operations are defined for that particular variable. So some of the common types for these values are integers, floats, strings, and booleans. Okay. So let's see some examples. So integers are whole numbers like 10 or -5. So you can see I have a variable named a, and I'm assigning 10 to that. And here I have a variable named myInt divided by underscores, and I'm assigning -5 to that. Floats are decimal numbers. We can define decimal numbers using this decimal point, 6.2 or -6.2, assigning to variable named b, or the value 0.123 as another float example, assigned to variable myFloat. Another data type is called strings, which are sequence of characters. So we already learned about those. If you want to define a name, for example, you can actually put them in double quotes or single quotes. So here we have an example of a name assigned to a variable. And here we have an example of a sequence of digits, right? So this is not a number. This is not an integer. This is a string because it's enclosed in single quotes. And then the last one is Boolean, which represents true or false, 0 or 1. It's a flag. If it's true, then basically you have some sort of logic, or it could be false, where you have another set of logic based on how you define your code. So, for example, true here is assigned to a variable named D, and false is assigned to a variable named is married or not. So true and false are reserved keywords in Python. You cannot assign any value to true or assign a value to false. They cannot be your variable name. Okay. So the next concept is typecasting in Python, which is the process of converting one data type to another compatible case. And it also ensures data consistency, especially when too many different data types are interacting with each other. So here in this example, we realize that this 12 is not an integer, it's a string. You can typecast it to an integer with typecasting techniques, right? So some common use cases, if you want to read numeric values from a user, so you know that the input function gets strings from the user. If you want to make it a numeric value, then you can use typecasting. If you have mixed data types calculations, you can use typecasting for that. And it also helps avoid type error, because if you don't properly use the typecasting, it will result in an error, which is a type error, and it's going to crash your code. Okay, so you're going to avoid that using typecasting. We have two types of typecasting. One is implicit, one is explicit. Implicit is when Python automatically converts one of the operands to the other data type. For example, here I have an integer and a float. When you sum them up, basically what's happening is Python implicitly converts one of these into the other, where it's converting 5 into a 5.0, which is a float, so that your code will not crash, and it will understand that these two are both numbers, and you can get this output from that. So this is called implicit typecasting. Another example of implicit typecasting is to use a Boolean inside your computation. For example, if you put a plus true here, it will add a 1 to the summation. The other type of typecasting is explicit typecasting, where the programmer explicitly converts the data type of a variable using built-in functions like int, float, string, etc. So let's say you're given an input from the user, the number 10, but it is a string, because we know that input gets the input from the user as a string. And then using the int function, you're trying to typecast that as a numeric value, right? So this is called explicit typecasting. All right, now let's see some examples. Okay, so if I go here, first of all, let's see some examples of primitive data types that we learned. First is a string. So I'm going to define a variable name with an underscore here, which is allowed. This is the name I'm going to define. Then I'm going to print the name. And then I'm going to print the type of the name. So type is another Python built-in function to show what is the type of that value. So if I run this cell, the name is printed right here. And then the type is a string, right? So here it's saying that this variable belongs to the class of strings in Python. So we're going to learn about class on week 3, but briefly mentioning, each of these data types in Python, there's a class written for that. And then when you create a variable, you're basically creating an object from the string class in Python. So that's why it's saying that the type is class of strings. So another example with integers, the variable is age1. I'm going to print the variable and I'm going to print the type. So this is the value and this is the type. And also note that string has a different color coding than an integer, right? So these are all different color codings on Jupyter Notebook. And also in different editors, you may see different color coding, or you can also change the color coding in the configuration of whatever software you're using. So for Boolean, I'm defining the variable named is married. It's set to true. And you see that it belongs to the class of Booleans or bool. And then for float, I'm defining GPA to be 3.7, and the type is a float. So you can overwrite the values to these variables. So first here I'm defining a variable named age, and I'm assigning an integer to that. And then I'm going to overwrite that variable with another value, which is a string, right? So you can overwrite the value to a variable within your code. So you see that this variable was an integer and then it became a string after this overriding. So a couple exercises I have here. I want you to think about it. I'm going to give you a few seconds. And feel free to put your answers in the chat. And then we're going to reveal the answers and go over that together. So for each of these, I want you to think about what is the output. So I have a code written here, and I have some prints. I want you to think about this and tell me what is the output. And as you can see, I'm using the end option, so you're not going to the next line. So you can put your answers in one single line. So what is the answer of this cell in one line, and what is the answer to this cell in one single line? So think about this for a few seconds, and we're gonna go over the answer together. All right, so thank you all for participating in the exercise. Please use the chat for these quizzes in the class. So the Q&A, let's keep it for questions during the class. So the first one, let me show you what the answer looks like. So here's how the answer looks like for the first one. So here we have this variable a. We're going to print it right here. At the end, there will be a comma with a space. And then right after that, we're going to overwrite this variable name, and we're going to print it right here. And then this is how the second print ends, which is right here. And then in the last one, we have another overriding of this variable with the Boolean value false, and then it will end by space and this special character and. Okay, so this is the answer to the first question. Now for the next one, let me first try to run this. So you'll see that there's a syntax error happening right in this line. So it says that this line right here, line 3, right? There's an invalid decimal literal. So basically, we know that we cannot start the variable name with a digit, right? So you can have digits in your variable name, but you cannot begin the name with digits. So that's why this line is not a valid syntax. There's a syntax error. If I remove this 3, then we will have a 121 right here. Okay, so the next thing is before, but I mean, even if that is correct, then we still have another issue here at line 6, right here. So now, this one is coming from the fact that we cannot have special characters in variable names. We can have underscores, we could have digits, not in the beginning, and we can have letters, both uppercase and lowercase, but we cannot have special characters in the variable name. Okay, so that's why this is wrong. So if I remove this, this should be okay. But then if I run this again, there's yet another issue on this line saying that you cannot assign values to the Boolean flags true and false because they're reserved in Python for Boolean. So you cannot assign values to them. So if I do true 1 here instead, then now everything looks fine, right? So we have 121 here after this operation, and we're ending with comma, and then here we have 50 times 2, and here we have a false written, right? Okay. Cool. Let's continue. So we had implicit versus explicit typecasting. So for explicit typecasting, I have this example here. Let's say we have age in a string form, and I'm going to typecast it as an integer, right? So we have this int function. We put this 25 right here, and we get this. So the type of age is now a string. Sorry, it was a string, but now the integer age after this typecasting is now an integer. Okay. So another example, if you have this age as an integer, you can typecast it as a string using the string function. Okay, so now it was an integer. Now this new age is a string. But this only works if these values are compatible. So in the next example, 25 written in characters, right? In letters. It's not, it's not convertible to an integer because these are all characters. So if I try to typecast it as an integer, then I'll get this error saying that this is not a valid literal for typecasting. Okay. So the other type of typecasting is Boolean. So if you have any values in this objects, then the Boolean becomes true. And if the value is none, it becomes a false. So for example, string 1 has some value. We typecast it as a Boolean here, and string 2 has no values, and we get a false for that, right? So true corresponds to having a value, and false corresponds to having no value. Okay. All right. So how about implicit typecasting? So we had this example on the slides. Let's say we have these two values, one integer, one float. If we add them up right here, then implicitly we get a float in the output because both of these are numbers. So 5 will become 5.0, and we get 7.0 in the output as a float. If you want to switch it back to an integer, you can actually do a typecasting and explicitly taking this float and converting it to an integer. Okay. And then the last example here, remember, if we get an input from the user, it will always be in the form of a string, right? So here we are getting user input. It will be a string, and it will be assigned to variable named user input. Then we're going to print it, and we're going to print the type. But then I'm going to also typecast it as an integer and then print it again. So let's say my number is I don't know, 23 again. So 23 used to be a string here, but after the typecasting here, it's now an integer. So in these next 3 lines, we're going to get integer for 23. And this empty print is just to give us a new line and some space in between these prints. Okay. All right, so let me go back here before going to the next topic. I see there are a few questions on the Q&A. Why does it return false in bools? Okay, so the question is here, why do we get a false here? So this is one other type of typecasting. So when you typecast as a Boolean, you're gonna get a true or false, right? So for numbers, if you have a number which is non-zero, then you'll get a true. And if you have a number which is 0, you'll get a false, right? So this is a Boolean typecasting for numbers. But for strings, if there are any characters in your string, you'll get a true for Boolean typecast. And if there's no character in the string, you'll get a false, right? So this is by definition. If you have any values, typecast by Boolean gives you a true. If you don't have any values, it will give you a false. So the next question is how to check if a variable's type is string or Boolean or int. Type returns a class or a string. So if you want to see the type of a variable, so this is a variable, right? If you write type string1, then it will give you the type of that, right? So this is the type, the data type of that object. This is string. Then we had, for example, int age is integer, and this could be a bool or any other type, right? If I put a print here, it will show class of int, right? So that's a bit of different when you put print versus not. So the reason it has this class here is because this object is an instance of the class of integers in Python. We have not yet learned about classes, what they are, but the only thing you need to know for now is that each data type in Python is actually a class, right? So a class is written for each data type. And when you build an object from that data type, it's basically creating an instance from that class. So that's why you see this class. But I mean, answering short is this function type gives you the type of that variable. Next question is confused with bool function. So bool function is basically just a typecasting, converting a variable to another type. So for example, if you had 25 here, then this int function will get this 25 as a string and gives you a 25 as an integer. This bool does exactly the same thing. If I put a bool, now it tries to understand this should be a true or false, right? If there is some value here, it gives you a true. If there is no value, it gives you a false. There is no point, don't get confused with this. This is just a definition. The Boolean typecasting gives you a false if there is no value for strings, and if there's a value, it gives you a true. So that's a definition. That's it. So there's a question that what is the shortcut to add a new row in the notebook? So if you click outside of the cell and the cell becomes blue, highlighted blue, then if you click on A, you'll get an empty cell above that. And if you click on B, you get a cell below that. So A for above, B for below. Okay, so these are the short keys for adding a new cell. And the next question is, even though Python allows dynamic typing, which one is preferred in production level code and why? And the codes are these two. So now you're referring to type hinting on these two lines, which is a topic for functions. So this is more preferred because it is more informative. It's showing some hinting, type hinting for each variable. But let me actually define that when we get to the functions in the next section, okay? All right, so now let's go to the next topic, which is operators. All right, so this is the last topic for the first part of the class. So here we're going to learn about 3 different operators. They're going to be arithmetic operations, or operations for a basic math, comparison operators, and logical operators. So for arithmetic operators, you probably have guessed we have the plus operator for addition, minus for subtraction. For multiplication, we have the star operator. For division, we have slash. And division will give us the float answer for the division. So basically 4 divided by 2, this should be 2.0. This is actually a typo here. 4 divided by 2 gives us a 2.0. And then if you are looking for an integer division or a float division, you'll get the quotient of the division by double slash. So 10 slash 3 will give you a 3, because the answer would be 3.333, right? And then the floor division would give you just 3, which is the rounded answer. And the modulo of a division is given by the percentage sign. 5 modulo 2 gives us a 1. So this is the remainder of a division. And then the power operator is double star. 4 double star 2 means 4 to the power of 2, which gives us a 16. Okay, so these are just some definitions of arithmetic operators. And then we have comparison operators. If you want to check if a number is greater than the other, you can use the greater than or less than operators. And this will give us, so these operators will give us a Boolean, a true or false. It's checking a condition, right? So if x is greater than y, the value, and then this will give us a true. If that's not the case, it will give us a false. We have greater than or equal, less than or equal. So similar definitions and greater than or less than, but now equality is added, right? We have equality operators. Equal is to check if 2 values are the same, right? So if x value is equal to the y's value, then x equal y will give us a true. Otherwise, it will give us a false. And then the opposite of that is the exclamation mark equal operator, which is not equal to operator, which will give us a true if these 2 values are not the same. Then we also have identity operators, which we're not going to spend too much time on it because it's out of scope, is to check if 2 variables are pointing to the same reference in the memory. So if x and y are referring to the same location in the memory, then this is operator is going to give us a true. Otherwise, it's going to give us a false, and is not is its negation or the opposite of that. So the difference between identity operators and equality operators is that in equality, we are looking for the values only, but in identity, we are looking to their occupying memory location. So I will show you an example of it, but it's not the scope of this class, and we don't really need that because we are not trying to, we are not looking at memory efficiency here. And then the last set is logical operators, and or not. So logical and, basically these operators are to combine operators, right? So, or combine conditions. So if x and y are both true, then x and true will give us a true. If either of them is false, x and y becomes false. And the next one is logical or, which is true if either of the operands is true. If both of them are false at the same time, then X or Y becomes false. And then not is basically the negation operator, right? So it's true if the operand is false. So if X is true, not of X is false, and then the other way around. If X is false, not of X is true. And then when you write them into a single on a single line, there is an order for those operations. So not goes above and then it's or. So usually when you have both of them on a line, not goes first, and then you look at and then or. So to avoid ambiguity between these orderings and everything, you can use parentheses, because parentheses has always the highest evaluation order. Okay. If I go back to arithmetic operators, so the order is always highest with parentheses, and then we have power, which has the highest order, and then these four operations, multiplication and all sorts of division operations, they come next, and addition and subtraction will be the last in evaluation order. Okay. All right, so let's go back here for operators. So let's see a few examples on arithmetic operations first. So I have two variables, both of them are integers. Now I'm going to check their addition. So you see that I'm using an F string here. I'm putting this addition here, and then A, which comes from this value, plus B, which comes from this value, is equal to A plus B, which is the summation of the two. So this gives me this nice output in the display, right? So this is why I'm using F strings here. So the summation is 7. The subtraction is 5 minus 2 gives us a 3. Multiplication using the star operator gives us a 10. And the power gives us a 25, because 5 to the power of 2 gives us 25. And we use double star for that. Okay. For the other arithmetic operations, we should know about division expression. So let's see an example here. Let's say we have this division. So we know that 5 is 2 times 2 plus 1, right? Now, if you want to divide 5 by 2, this 5 will be called the dividend. This 2 is called divisor. And this 2, which is the result of this division, is our quotient. And this 1 is called remainder, right? Now, each of these operations gives us a component of that. So first of all, A slash B is going to give us the float answer, right? It's going to give us 2.5. But if you want to get the quotient, you can use double slash or floor division, which is basically truncating the decimal points of the division. And then the remainder, you can get it with the modulo. So A modulo B gives you 1, 5 modulo 2, which is the remainder of your division. Okay. So we have operator plus assignment. So similar to other languages, you can actually make it easier to perform an operation and then assignment in one shot. So let's say you have two values, 5 and 10, and you want to add up these two and assign it back to one of these two variables. So let's say I want to add them up and then assign the result back to B. So 5 plus 10 is 15. I want B to be incremented by 5. Instead of writing this, I can also write B plus equal A. So these two are equivalent, right? So this is called addition and assignment. So we are adding B by 5, and then we're assigning it back to B, which makes it 15. Okay. If you want to increment by 1, now you have this value, you can just plus equal that 1, which is your increment, and it will increment your value by 1. So you may have seen this by a plus plus in some other language, but in Python, you can use plus equal for that. But you can also do this assignment with any other operations. You can pair them with other operations that we learned already. If we have multiplication and assignment, for example, we have 10, then b star equal to, we'll multiply this 10 by 2 and then assign it back. Or division equal, we'll divide this by 2 and assign it back, right? So these are all valid. Then we have comparison operators. So if you have these two values, we're going to check different comparison operators. A less than B is true, right? So is A less than B? The answer is true because 15 is less than 20. A equals to B gives us a false because these two values are not equal. A not equal to B is true because these two values are not equal. A greater than or equal B is a false. Okay. So remember that all of these things, all these comparison operations, so this will give us a Boolean at the end. So a Boolean is a variable, is an object. So you can actually collect that value inside a variable, and then you can use that variable in the logic of your code. So here I'm collecting A greater than B, which is a false, into X, and I can print X. Or you remember that there's implicit typecasting of Boolean. For example, x plus 1 gives us a 1 because false is considered as a 0. Implicitly typecast as a 0 plus 1 gives us a 1. Okay, so you can use this x later in your code. So we learned about equality versus identity operators. Quickly going over one example to show you the difference. So we have a function in Python named ID. It will give you the identity of an object, or basically the memory location mapped into an integer. So we have these two variables and their IDs are equal, right? So this is the case for small integer numbers. Now, if I print equal B and is B, they both give me true because both the values are the same and also their identity are the same. Okay. Now, later we're going to learn about Python lists, and we know that two lists, even with the same values, are stored in different parts in the memory. The reason to that is because they are mutable objects, and mutable objects are stored in different parts of the memory. So their ID are not the same this time, so they're different. So if we look at these two operations, we get true for equal because the values are the same. But we get a false for the second one because they're not stored in the same location in the memory. Okay. So basically, these are two separate objects. They just happen to have the same value. All right. So the last set of operations we're going to learn are logical operators. So let's say we have A and B, which are true and false. We have three conditions here: A and B, A or B, and not A. So one by one, they're going to give us false, true, false. Why? Because A and B gives us a false because in order for AND to give us a true, they both have to be true. If either of them is a false, then it gives us a false. A or B is a true because A is true, and either of them is true gives us a true, and not of true will be a false. Okay. All right. Now I have an exercise for you. I'm going to let you think about this for a few seconds, and then you're going to go over the answer together. So I'm going to pause here and let you think about this exercise. Please use the chat option to put your answers. Do not use Q&A for this. So I'm going to look at the answers in the chat mainly. Okay, so I'm going to give you a few seconds on that. All right, so let's go over the answer together. So the right answer, so I see there are lots of answers in the chat. I think they're mainly correct. So the right answer to this one is false. And the reason to that is going from left to right, we have two parentheses. So the first one is a false or true. So let me actually do this. So the first one, false or true, gives us a true, right? Because or will be a true if either of them is true. And then now there's no parentheses. Then we look at the next one. Inside the parentheses is another one. So this and will give us a false. And okay, so inside these parentheses, we have or and we have not. Not has the highest priority. Not of false is a true. True or true will be a true, right? Okay, so now here, and not has the highest priority, so this will give us a false. Then we have this and here, which will be false, and then the final or gives us a false. So the right answer to this one is a false. All right. Now, couple things here. If you look at this thing, and then there's or false, right? Then the final answer will be whatever answer we can give to this one, because anything or false will be that thing, right? So if this is true or false, then it will become a true, and if this is false, it will become a false. So we could remove this part from the question. So that's one trick. And then what's the other? So is there anything else we can refer to here? Okay, so inside this parentheses, we have true or something. So whatever this something is, because we have a true here, this parenthesis could become a true, right? So this will always be a true. And because we have and true, then the answer to this part would always be whatever comes here, because anything and true will be that thing, right? So these are some tricks that you could use actually to come up with the answer more quickly. Okay, so that was our last example. Before we go for a break, I want to make sure that there are no questions left. So I see there's a question that in the A-B example, will it not make a local copy? Then why ID of A is equal to ID of B true? So I think you're referring to this question. So if you're referring to this question, this one, when you have strings, especially for small values of strings, then even if you have two variables with the with this value assigned to them, they will both be referring to the same location in the memory. So they don't have a separate copy of that value. Okay, so that's the thing with the integers. So it will be different from different data types, and we're not going to go over all the details there. But that is different for lists. So when you create a new list, you are actually creating a local copy, and that will be a different storage in the memory. So that's why we see a false here. But that's not the case for integers. For integers, you're going to refer to the same location in the memory. I think this will be different if you increase the integer beyond some threshold. I don't remember the exact value of that threshold, but for small integers, it's always the case that there's only one place in the memory assigned to that. Vijita, you have a question?
Yes, I do not understand this. So if two variables have the same place in the memory, how can we work differently on them? Like I want to have a different logic for A in future and different logic for B. We're working on the same reference. How will it work?
So it's not gonna make a change in your in the logic of your code. So if you these two are independent. So if you have A plus 1, or let's say A plus equal 1, then that would be a 2. And if you have a B plus equal 2, that would be sorry. So we should run this again, and then that will be a 3, and this will be a 4. Okay, so and then these two will be independent. If I print A and B again, their values will be different. It's not that you're pointing to this memory location, and then they're stuck to the same value at the same time. When you move from this value to some for example, neighboring value, then it is actually pointing to another part of the location in the memory, so independently from the other variable. Okay, so then that's the thing for integers. So for integers, this is how it works, but this is not the case for list. So these are referring to the same location in the memory, but they're two independent variables. So this is how you should think about it. Does that make sense?
It does not to me. I'm sorry. I come from C++ background, and it is just just the opposite of what we've learned. Like memory is the place where the values are stored, and if we are referring to that memory location and anything goes in there, then it just does not make sense to me. Is there any
Okay,
material
so
I could refer to understand this better?
sure, yeah, I will definitely share a link. So there's definitely a lot of difference, especially if you're coming from C or C++ background. This is definitely the definitions are a bit different here, but let me actually share a link so that you can learn this better. Link to memory. So I will put a link for further reading on this one. Thanks for the question, Vijita. Let's go over the next questions. So I see there's a question that if we ID A and B again, yes, if you ID A and B again after making change to the values, then their IDs will be different. That's right. The next question, you don't directly change memory location? No. So I'm not changing the memory location, I'm just changing the value, but for strings, that value is attached or mapped to a particular memory. And then the next one is when and why do you use print ID? We don't actually, at least in this class, we don't. That's when you want to actually work on memory allocations, and yeah, I haven't really used it for a while, so we don't really use it in this class as well. But just wanted to show you where that memory identification comes from. So next question, since the ID 434 appears to be the ID for the value 2, and the variable just points to it. I think you're answering a question, Abhinav. I see also your hand is raised. Maybe I can let you. So Abhinav, do you have a question?
Yeah, and I apologize. It was just a continuity of my previous comment where I said that A and B, if we change the value of A to, let's say, 3 and B remains at 2, then their IDs will become different because it's the value 2 which is mapped to a particular address, which was starting with 434,831, blah, blah, blah. And A and B are just pointing to that. It is sort of, yeah, it can be a little bit counterintuitive, but maybe that's how it is defined in terms of Python. But I think that's that's just my mental model of understanding it. Right?
Yes, that's exactly the way it's defined. So when the value is moved, then the ID is attached to that for integers, but that's not the same for other data types. So for mutable data types, then as soon as you create an object, you're going to get a different memory location, and then even if you change that, then you're going to see a different memory, which is still different from the original one. But yeah, so yeah, thanks.
Can I ask one more follow-up question?
Sure. Yeah, please.
So I think you did mention that this phenomena or this setup is finite. So not all integers are mapped to their own specific locations. It's up to a certain point only, maybe for memory speed optimization, etc. reasons. First of all, did I hear that right?
I believe so, yeah. So I think I don't remember the threshold to that, but I think after some threshold of the size of the integer, then we're going to get to different realms, right? So you see that the memory is different right now. Yeah.
And one more question was that the equality operator equal to appears to be quite powerful. It's able to compare these two lists content, but there has to be a limitation for that as well, right? Like for example, about complex objects comparison, all of those. So there should be a concept of implementing your own equality operators as well when it comes to really complex objects.
So by complex objects, you mean like instance of a class, for example, right?
Yeah.
So if you're working,
sorry. So let's say a dictionary or a hash map of a complex class and associated values and not in sorted order. So if I want to compare those, what I'm saying is there has to be a reasonable limitation onto this fairly powerful equality operator, which was able to quickly compare these two lists as the same.
Yes.
So if this was, let's say, 3 to 1, for example, if B was 3 to 1, would it still say true?
Yeah. So I understand your question, and then yeah, if you're defining your own class, then there are ways to customize equality between different objects of that class as well. But in this simple case, when this is 3 to 1, then these two values are now different, so this should not give you a true. So we have this equal working to some extent for primitive data types, and then a bit more data structures that we're going to learn. So this is going to work fine for sets, for dictionaries. But then when you get more complex, when you define a class with custom defined objects, then you can define your equality, what you want this equality to mean. So that's in your control. Yeah.
Thank you very much.
Thank you, Abhinav. So other questions, functions stuck to memory location, primarily a variable. I think we discussed this one. ID of A. So the question is, will this ID of A will always be the same? Yes. So if you run this multiple times, you see that it will not change. It will always be the same. But if you run the one with the mutable data type, that will change. That's the way it works for mutable objects. So the other question is, what is the usage of ID in real projects? If you're working with memory, and if you're any operations on memory, then it will be helpful. I haven't used it in any of my projects really, but if you want to check anything memory related, you can actually use that. More like, will the answer change after a few days because the original location has been used for something else? Memory location. I'm not sure if I follow the question, but I think your question is aligned with the previous question. So this memory for an integer is always fixed, but not for mutable objects. For mutable objects, the ID will be different each time you get the ID, each time you create an object. Okay, so let's, these are all great questions, but let's not focus much on this ID function. So I just brought this here for you to see this is and is not operators. But we are not going to use that at all in this class. We are not going to get to any memory efficiency or anything like that, right? So we care more about the values and how we can use these operations to solve problems, especially, right? So let's not focus on that, and just let's keep this in this notebook. And I also provide that link here somewhere to show you what's going on here actually, but let's keep it at that. Okay, so we have covered the first part. So we went over the basic concepts, and we covered variables, data types, and typecasting. And we also learned about arithmetic, logical, and comparison operators. Let's take a short break, and then after 10 minutes, we'll be back and continue with conditional statements, loops, and how to define a function in Python. All right, so we'll be back in 10 minutes. All right, we'll come back. So let's move on. We're gonna now learn about conditional statements, loops, and functions, and how to write them in Python. So I'm gonna adjust the pace of the class a little bit because I think we have too many topics left and not much time. So let me go a little bit faster on this one. So writing a conditional statement. So first of all, why do we need them? We need them to allow branching in the code based on multiple conditions. Sometimes you have a condition and you want to make a decision based on that. We can use if, else, and else if, or in Python, elif keywords to set up this kind of structure. So we learned about indentation in the beginning of the class. So Python uses the indentation to identify code blocks. This is one of the use cases that we need to make sure that we are following the indentation convention for defining the code block in the conditional statements. So the syntax looks like if some condition, and if that condition is true, so this condition will be a Boolean. If it's true, then we go inside that block, and then this part of the code will be executed, and then the rest of the conditions will be ignored. But if that condition is false, then you can add another condition to check, elif condition 2, and if that's true, then you go through that block. And then if all the conditions are false, then there's an else, which will be kind of like an otherwise all these conditions, then you'll execute the last block. You can have multiple of these conditions using multiple elifs, or you can have no elifs. If you have only one single condition, then you can have only one if, and then the condition, and then the corresponding block, and otherwise you can actually have another block as well. Or if you can just have a single if block. If you just want to check something and as a flag, you can only have if and some logic, and that's it. There's no else there. You can combine conditions by using logical operators we just learned. You can use and, or not to get more complex conditions. And you can have nested conditional statements. Basically, you can have an if and else inside another if and else. So that's also allowed. Some best practices: make sure your conditions are simple and readable. You can use parentheses to add more clarity when you're trying to combine those conditions. Okay, so let's go back to our notebook. Let's see how we can write if and else statements in Python. Our fixed example is giving us two different variables. Both of them are integers. So one is age, one is threshold. And we're going to check based on comparing these values to see if the someone is allowed to vote or not. So basically, if the age is greater than this threshold, which is 18, we check that condition, and this is going to give us a true. So if this is true, we're going to go into this block, and you see that there is an indentation here with 4 white spaces, and we're going to print this statement here. If this condition is not true, then we go to else, and this part will be executed. So in this case, because 25 is greater than 18, we get the first line. But if here this was 17, then we would get the second line. Okay. So a couple of things to note here. If I so after the condition, we have this colon, right? So after that, if I press on return or enter, you'll see that the code block or the indentation is already given here. It's implemented, right? So you can actually stick to that if you don't want to think about how many white spaces you need. And yeah, so that's it for this example. So the next one is for arithmetic operators that we just saw in the previous section. So here we are given this number, and we're going to check to see if this is an even number or odd number. So if it's an even number, by definition, its modulo by 2 should be 0, right? So all even numbers are divisible by 2. So if this condition is true, then we're going to print that this number a is an even number. If that's not the case, we're going to print that it's an odd number. Okay? So again, here's our condition. We are putting it into parentheses just to make things more clean, but you can actually remove the parentheses, and that works fine too. And then after the colon, we have this block of code, which shows that we are inside the if block. And then after the else, we have another block. Okay, so running this, it will give us 10 is an even number because we are inside this block, because this condition is held true. But if 10 is 11, then we go to the else block, giving us 11 is an odd number. Okay. All right, so the next example is combining multiple conditions. So let's say we have the age, which is 25, and another variable has license is true. Okay? We're going to check both age and license to check if someone is allowed driving or not. Okay, so now in this condition, we have in this case we have two conditions, and we have to combine them using AND. So if age is greater than 18, and the person has license, right? So if both of these are true, then we're going to print driving. Okay. Now the next condition is if age is satisfied, but they don't have license. So has license is not of has license is true, which basically means has license is false. Then we're going to print need license. And then the last option is, the driver is underage. So basically, the only option left is that the age is less than 18. Okay, so because age is 25, driving is allowed. If license is false, they need license, and otherwise, they are underaged for driving. So note that I just put has license here because the value is a Boolean. But if you remember, with implicit typecasting, you can have other values for has license, and it will implicitly typecast it as a Boolean to check here for the conditional statement. For example, if I put 1, it acts as a true, right? So let me go back to 25. So it acts as a true. If I do a 0, then it will be it will act as a false. So we'll activate this second part of the conditional statement. Okay. All right. Now I want you to think about this this code for a few seconds. See if you can find the answer to this one. So the number is 14, and see if you can see which print will be activated and what is the output. Put your answer in the chat, and then I'm gonna go over this, go over the answer. All right, so thanks all for the responses. I see both D and A in the answers. So let's see what is the right answer here. So the right answer is D, which means the code is routed to this part to print this D. Let's see why. So the first condition, so we have an example of a nested conditional statement here because we have if and else inside if and else, and actually we have multiple of them. So first of all, note that when we get into the first block, we have one indentation, but then we have another block inside this inner block, which has another indentation, right? And then inside that, we have another indentation. So that's how the interpretation of a code block happens, right? So first of all, we're checking if num or the number is greater than 0 or not. Because we have 14, then we have greater than 0, we go inside this block. Okay. Now we're checking if this number is divisible by 3 or divisible by 5 or none, right? So, or not. So 14 is not divisible by 3, is not divisible by 5. So we go to else. So we're going to go into this block. Then we're going to check if the number is even or odd. The number is even, so we go inside this block and we're going to print D. Okay. So you can check other functions on your end. So for example, what happens if we have 15 here, then the number is divisible by 3, then something happens here, and then divisible by 5, we're going to print C. But because 3 comes first, if you have 15 here, it goes into that block instead of the second block. And then if the number is negative, it will check if it's less than -10 or greater than or between 0 and -10, and it will do a different, there will be a different logic based on that value. Okay, so now I'm going to introduce the notion of ternary operators for you, just to let you know, because you may see this here and there. So I'm gonna write a similar code but using ternary operators, and ternary operator is just to write an if and else statement in one single line. So let's say I have a condition of checking if a number is greater than 10 or not, and if that's true, then I'm gonna basically summarize the second conditional statement or the inner conditional statement in one single line. So I'm going to print A if a condition holds. So my second condition is this one. I'm putting it right here to make things a bit cleaner in my inside my conditional statement. And else I'm going to print B, right? So basically, I had these few lines: if condition print A, else print B, right? So these 4 lines is now packed into this one single line. So this is what we call ternary operator, where we combine all these components of the conditional statement to one single line. So if number is greater than 10, we're going to print A if this condition holds, and we're going to print B otherwise. And if this is not the case, same thing on this line. Okay, so for example, 14 is greater than 10, and it's an even number, so we're going to print A. Okay. Now, it's up to you to understand what is a good, what's a good time to use ternary operators in your code. So you can make your code look more readable by using ternary operators, or you can actually make it look very messy and hard to read. So actually, these 4 lines can be written into one single line, because we can have another ternary operator using this condition. So we can have print A if condition, else print B. If this condition holds right here, else do whatever comes on this line. Okay. But it's a bit hard to read, right? So it's not easy to follow, and it's not a good coding practice, really. So it's a good tool to make your code clean and more readable, but if you overuse it, then it could actually get quite messy and hard to read. Yeah, so this should give us the same answer as the other one. All right, let's go back here. Before I move on to loops definition, I want to see if there are any questions. Let me check quickly here. Okay, so I don't see any questions. Just one quick note. When we have questions in the class and I want you to work on any of these problems, please answer them in the chat, because the Q&A is for class questions, like questions from any topic. So if there are any quizzes or class activity, please put your answers in the chat. Just keep the Q&A for TA. So think of Q&A interaction with TA. Okay, so that would be easier to for us to track your answers to the quiz and answers, or answer your questions in Q&A, and they won't be missed. Okay, so let's move on to the next topic for loops. We have 2 types of loops in Python. So loops are designed for iteration through some sequence. So let's say you have a particular code that you want to basically execute based on a list of items, right? So it's not just a single item, but a list of items that you want to actually write the code for. So we have 2 types of loops in Python. We have for loop and while loop. So for loop is defined for iteration over a sequence. For example, a list of items, a tuple or string. A string is a sequence of characters. Tuple we're gonna learn about next week, and list we're gonna learn about today. But all of them are basically a sequence of items. The items could be different in their type, but they're still a sequence of items. So it's a limited list of items. But while loop is defined for code execution while a condition is true. Okay, so this loop can go forever unless there is a condition that is violated, and then bring us out of that loop. So this is not similar to for loop, because in for loop the iteration will continue until we get to the end of the sequence. But for while loop, we will have the iteration until some condition is violated. Okay, so this is the main difference between the for loop and the while loop. In many cases, you can actually write a for loop as a while loop and the other way around, but it's about the convenience and the ease of implementation, right? So sometimes for some idea, it's much easier to write it with a for loop, or it's much easier to write it with a while loop. So we usually go with the best coding practices in those cases. We have also loop control statements. So let's say at some point you're just gonna get out of the loop immediately, or in some sense prematurely, without completing all the sequence. You can use the break, and then you can use continue to skip the rest of the loop for the current iteration. So sometime at the current iteration you don't want to continue anymore and you want to go to the next iteration, you can just put a continue, and it will take you to the next iteration in your loop. So the next is the concept of nested loops. So this is similar to nested conditional statements. It's basically a loop inside another loop. Okay. So it's highly recommended to avoid nested loops. Just use it if if you really need it, because nested loops, unlike nested conditional statements, could lead to time complexity inefficiencies. You're going to learn more about that in other classes, but the idea is that you're basically doubling up the runtime of your code, which is not a good coding practice. So also try to keep the bodies of the loop header as simple and readable as possible. So let's see a few examples of that. So first of all, I'm going to introduce a new built-in function in Python, which is the range. So when we say range of a number, then it's going to give us an object from a particular class in Python, which provides range of numbers from 0 to that number. And usually when we write a range of 5, it basically starts from 0 going all the way to 5, but exclusive of 5, which means 5 is not included. So if I show that as a list in Python, you see that this is the list of numbers that the range of 5 will give us. It's 0, 1, 2, 3, 4, and 5 is not included. Okay, so we should get used to this concept of exclusion of the last element in Python, because that's how it works. Okay, so now to write a for loop. So we have for as a built-in keyword in Python, the name of the variable that we use in each loop. In means checking all the elements inside whatever object comes after that. And then we have a range, right? So this range is a sequence of items, in this case, sequence of integers. And this for loop is going to meet all these integers one by one. So we start from here, and then here, here, with the same order, we go all the way to the end. And each time, now you see we are inside the for block, right? So this is a block inside this for loop. Each time we're going to print a value, and we're going to end it with some white space. So this is what we're doing there. It's very simple. You can have multiple lines of code here, but here we're just trying to see what a for loop does. So each time is printing a number, which is that the number for that particular iteration in the loop, and it will end it with a white space. Okay. All right, now what if the range has 2 numbers? So here we only had 1, but if you have 2, then it will start from the first item and it goes all the way to the second item, exclusive. So it starts by writing 10 in the output and going all the way to 14. Okay, so in this case, we are actually defining the beginning and the ending of a sequence. And then if the range has 3 numbers, the first 2 will be defined the same as before, but this last item is the step size. So in this case, we start from 10, we skip 11, and we jump over to get to 12. So with step size of 2, we go from 10 to 14 that we had. A couple other examples for loop. So let's say I want to find the sum of some numbers. So I define this variable sum starting from 0. inside this for loop, let's say I want to find the sum of numbers from 1 to 4. So I go in the range of 1 to 5, which gives me that sequence of numbers. And each time I use the addition and assignment original initiated here. So this is going to give me 10, which is 1 plus 2 plus 3 plus 4. Okay. So we have a function for that in Python. It's called sum. So the reason I'm using sum in all caps here is to avoid overwriting this function sum in Python. So you can basically use this sum to get that sum of values. So now let's say instead of adding up 1 to 4, we are actually going to concatenate these digits. So this is going to be a string of 1, 2, 3, 4, not adding up the numbers one by one. In that case, I'm going to initialize a new variable. I'm going to name digits. And I'm going to go in the range of 1 to 5, or in this case, 1 to 4. 5 is exclusive. And each time I'm going to concatenate the string of that digit. So each time I'm going to get a digit here, which is an integer, and then I'm going to typecast it explicitly as a string. And then I'm going to concatenate it with my original variable here. Okay. So in that case, we'll get 1, 2, 3, 4 instead of 10 here. Right. So because now we have a string concatenation and not a integer addition. Okay. So the next is how to define a while loop. So here we start by initializing our variable count by 1, and then we are going to start a while loop right here. But then the definition is a bit different from for. You see that there's no range of values, but a condition, right? So we have a condition which checks to see if this value is less than 5 or not. So while this condition holds, we are going to do these things. And as soon as this is violated, we're going to get out of this while loop. Okay, so we're going to print a number and then concatenate it with a string version of this count. But we are also going to increment count by 1 each time. And then as soon as this count gets above this threshold, which is 5, we're going to get outside of that loop and we're going to do this print. Okay. So if I run this, we're going to get something like that. So the only way we get out of this while loop is by having this condition violated, or somewhere inside this while loop we break out. Okay. So the next two are loop control statements. So first one is break. Let's say we are in a for loop from 0 to 4. If we get to 3, we're going to break. Otherwise, we're going to print it, right? So in that case, we will print 0, 1, 2. And because at 3, we are breaking out of the for loop, there's no 3 and 4 here, right? And then the next one is continue. So we're going to print 0 to 5, but whenever we get to 3, we're going to jump over, right? So we're going to skip that. So continue is to basically break the current iteration and go to the next iteration. Okay. All right, so before going to the next topic, I'm going to give you another activity for the class. So I want you to practice with for loops and while loops and try to find the sum of digits of a given number. So let's say I'm giving you the number 5132. I want you to write a code which gets this number and gives me 11, which is the sum of the digits of that number. So I'm going to give you a few seconds on this, and yeah, we were going over the answer together. All right. So for this question, I'm going to show you a couple ways to do it. So let me actually put the code right here. So first of all, let's say this n is 532, and our result that we're gonna print out is 0, right? So we're gonna begin there, and then I have two ways. So let's call it solution 1 and solution 2. So solution 1 is basically using what we learned in the operators for arithmetic operators, and then the way we can do operation and assignment, right? So while this n is actually has a value, it's not 0, right? We're gonna keep truncating it. So the result is gonna be that number modulo 10, right? So what's happening here is we're getting the last digit on the right, and we're going to add it to the result. So in case of 5132, we're going to get the last digit, and we're going to add it to this result, which was 0, right? And then we're going to cut that digit, right? So we're going to cut that digit by 10, which means that divide this number by 10, and then cut the value after the decimal point. So this line will give us a 513 after this line. We're going to have that truncation. Okay. So we're going to do this in a while loop because each time we get this last digit and then we cut it, so it will become a 513, and then we add it to this result, and then we're going to cut the next one, add it to the result, cut the next one, and the next one. And at the end, we have a number which is 0. And then when it is 0, then we get out of this while loop. Okay, so let's see what will this give us. So print result, give us 11, right? So this is the right answer. Okay, so the next way to do that is I'm gonna create a string from this, right? So I'm gonna switch to from n, I'm gonna do a string n, and I'm gonna typecast it as a string. So in that case, now I have a sequence of digits, right? So I don't need to worry about how to loop through these numbers. So now I go to I use a for loop. So for I in string n. So or I can say for digits, right? For digits. So I'm going to name that variable digits. So I'm going to go through those sequence of characters one by one from left. And each time I'm going to switch back to an integer. I'm going to typecast it as an integer and add it to the result, right? So result plus equals the integer of digits. Okay. So this way, by using typecasting, I'm actually getting a sequence of digits, which I can go through one by one, and each time convert them back into an integer and add them to the result. Okay. So if I comment this part out, this would also give us the same answer. Okay, so before going to the next topic, any questions on this problem or any of the topics? On loops. So I see there is a question and also hand raised. Abhinav, you want to ask your question?
Yeah, so in the second solution, you are actually doing a for each sort of an implementation, right? Because we never really identified the range explicitly.
Yes, exactly. So which solution do you mean? So the
Solution 2.
Okay. Okay, great. So for solution 2, we are looping through a sequence of digits, right? So let's say, let me actually print this right here. So I have typecast my integer into a string, which has 4 characters. Now, when you use for loop, you don't need to define a range for this. You can simply go through these one by one and get the value, right? So you can loop through 5, 1, 3, 2, get the value and use the value right here. There's another way I can do this. If I want to use length, I can use for index I in range of length of this string, right? So what's happening here is I'm getting the length of the string, which is 4, right? And I'm gonna use range of 4 to go from 0 to 3. Now, what I can do is I can add up, instead of the value of digit, I use string n at that index. So now instead of the value, I have the index, and at 0, I have the value 5. So when it's 0, this thing gives me value 5. And then at 1, it gives me a value of 1, and so on. Okay. So the reason I didn't mention this yet is because we're going to learn about value accessing in the last part of the class, when we learn about strings and lists. But both of these ways are fine. We can do both.
So, but in Python, are they the same way? So the reason why I'm asking is that I come from a C# background, and there's a difference between for and a for each loop. I understand the difference in the way you implemented it, but conceptually, I wanted to ask that in Python, do you see this as doing the same thing, or do you see this as doing two different things with a nuance?
So you're not doing the same thing exactly. So you're actually getting the value here and getting the value by index here. So these are two different ways of accessing the value. But if you're thinking about operational efficiency, like time complexity, then yes, these two gives us the same complexity of the operations.
All right. Now this is very cool. I mean the aspect of the range implied within the string, that is also implied to more complex objects, like for example list. So if this was a list of strings or list of integers, would I have just said for digit in that list and it would have done the right thing by itself?
Yes, that's correct. And we're going to actually see examples of that too. Yeah.
Thank you.
There will be another function as well, follow up to your question. It's called enumerate. And enumerate is going to give us both index and value at the same time. So I'm going to show you an example of that when we get to the part at the end on iteration through lists and strings. Okay, cool.
Awesome.
Thank you.
Thank you, Mark.
Yeah, awesome. Thank you. I see there's another hand raised. Milind?
Yeah, right. This is Milind. The one question, I think it was answered, but I just want to clarify. When I see all these complex functions, I know these are not complex, like list, and other functions we're using, and we'll have a lot more functions coming up in Python. So,
yes,
is it advisable to just go by those functions, just follow the crowd, or make it more efficient by writing your own little more efficient function? The question actually was, all these, are they like zero cost functions? Like in Rust, most of the functions you see, those are like very fancy functions, but they are all zero cost, which means you don't get penalized for using them. It will do the exact same logic behind the scenes, but that may not be the case in Python. So that's why I'm asking, is it advisable to use whatever libraries we have, all the functions as it is, or you don't have to recreate the wheel, but sometimes you think that a simple loop will actually be faster in the mind. You'll think like that instead of using this. So what do you say?
Yeah, so the answer to that is, without getting too much out of the scope here, but if you're going to use, if there's a function in Python that you have the option to write it from scratch or use the built-in function in Python, then usually the implementation in Python is the fastest and most efficient. But that is not going to answer the question of, is this the right data structure to use? So you can actually choose to go an inefficient route and then use Python functions, and then you're going to get the answer, but probably it's not inefficient. In those cases, you need to understand what is the right data structure and what's the best and most efficient way to do it, and then use the right Python function to that end, right? So in short, yes. So you can use those functions with zero cost, because that's the very efficient way to implement it. Especially when you look at sorting or searching functions, then Python does it exceptionally, right? But now the thing is, the other question is, shall we do that on interviews or not? That depends on the interviewer, right? So it's on them if they let you use Python functions, or they want you to actually use everything from scratch, just the basics like for loops, if and else, and then write up everything, the solution from scratch. So that depends on the person who's interviewing. But yeah, so hopefully I answered the question. All right, so I see that there's a question. I think I answered the first one. Any complexity difference between solution 1 and 2? So the answer here is, so both of these solutions are linear in time complexity because we go through all the digits one pass. But so the second solution is actually doing this twice, because we have a conversion in the first line, and then we are going through each item in the sequence. Overall, they are both linear, so they're comparable in complexity. But the second one is, I mean, if n is super large, then this typecasting may make the first solution even more efficient than the second one. Okay, so let's go back. So we're done with the class activity. Then let's go to the last topic of this section, which is how to define a function in Python. Let me swap windows. Okay, cool. All right, so what is a function? So a function is defined as the mathematical way of defining a function is pretty similar. So it's a reusable piece of code that will perform a specific task, and it helps with the modularity of the code so that you don't need to write a single functionality multiple times. It's much easier to maintain the code because now you can make one single change and see the effect of that change propagated through the code wherever this function is called. So we call functions methods when it gets to object-oriented programming. So whenever I say a method instead of a function, I basically mean the same thing. But the reason I say method is because this function is probably defined for a particular class in Python, and this method is one of the functions of that particular class. So I may interchangeably use functions or methods when I'm going over these slides. So when you want to call the function, you basically write the name with the parentheses, and if there are any input to the function, you need to put in the parentheses. So here's the syntax of a function. So we have def or define space, and then the function name, and then you have the parentheses, and all the parameters or arguments will lie in those two parentheses. And then you have the body of the function where you write your code, and then you have the option to return some value from this function. So basically, if you consider the basic definition of a function is a machine which has an input and an output, right? So there's an input, some stuff happens inside that machine, and then you'll get an output, right? So if you want to have some output from the function, you'll have this return keyword, and then whatever comes after return is something that the function will return. But it is optional. So if your function only does some processing and there's no output, then there will be nothing after the return. Yeah. So for example, down here we have a function named greet, and it takes nothing. There's no input. It only prints some statement, and it also returns nothing. So there's no output. By default, if there's no output, the function is returning a none value type. Okay, so it returns none by default. Okay, so a few points and examples. So again, on the return values, functions can return a value using the return statement. If no return statement is used, the function returns none. Like this example here, it only prints something and it returns nothing, so it will return none. And then there is a definition of parameters versus arguments. So I said that I keep using parameters versus arguments interchangeably. So parameters are the variables defined in the function signature. So when you define a function, you put a variable name here. This is what we call usually parameters that are the input to the function, right? But the arguments are the values passed to the function when the function is called. So when you're going to call this function in your code, you write the name of the function, and then inside the parentheses, you put the value that you're going to assign to that parameter. So this is what you call an argument. Okay, so this is the formal definition of parameters versus arguments, but in practice, you see people maybe use this interchangeably, and that's fine. But this is the formal definition of each. So the last point on this set, on this part, is the default parameter values. So sometimes you actually want to assign default values for the function parameters. So for example, in this case, I have a variable or a parameter with this name, and then I'm going to pass a default value to that, which will be used if you don't provide any values for name when we're going to call it. So for example, I have this definition of the function named greet, and for this parameter name, I'm assigning a default value world. And when I call that function later in my code, then I don't have to provide any argument for this parameter name, right? So if I don't do that, it will go with the default value world. But if I provide a value for that, then it will override that value, and the output will have the effect of the new argument. Okay. So one important note: non-default parameters come before default parameters. So this is a design note in Python. When you have multiple of these parameters, when you define a function, you have to put all the default values at the end, right? So you first begin with all the parameters which are non-default, and then you put all the parameters that are default. Okay, so that is by design. All right, so let's go back here. Now let's see some examples for functions. Okay, so the first example is the greet function that we saw on the slides. It's going to print hello, and it's not going to return anything. There's also no input. So when I call this function in my code, it's going to print hello, right? But if I print this function, because it's not returning anything, it's just going to print hello, and then it's going to print none, right? Because what it returns, which is going to be printed right here, is a none value. Okay. So just to help you understand this better, so let's call this function and collect what it returns. So when you call it and collect the value, it will print that hello, because whenever this function is called, it will print hello anyways. But now we are going to collect that returned value, and then when I print it, it's a none, right? Because it doesn't return any value. Now, the next example is kind of similar, but now we have a parameter passed to this function. So we get this name, and then we have this string concatenation printed out. So to call this function, I can write the name of the function and then add the string, right? So it will concatenate the two and passes hello John as the output, or as on the display. The other way to call this function is to write the name and then also write the name of the parameter and assign the value right there. Okay, so this is another way to do that. It's a better coding practice because it avoids confusion with other parameters. There's also one other thing I wanted to show you here. So the other way to define the function signature is by using type hinting. So the way it works is that after each parameter, I have a colon and then the type of that parameter. Okay, so I'm saying that I want to get a parameter here as input, which is a string. And then there is this arrow at the end, which is saying that this function is going to return a non-value. Okay? So type hinting is optional; it's not mandatory. And then it's a very helpful tool to show the user of your code what are the types of these parameters and the output of this function. But it's not enforced. So if you use type hinting, it doesn't mean that, for example, this name has to be a string within your function, right? But the best practice is always provide type hinting in your code, and also if you provide some type here, then stick to that. Okay. All right, another example is arithmetic functions. So let's say I have a function to add two numbers. I'm going to get parameters a and b. And then instead of adding them up, I'm just going to add a plus 2 times b, right? I can also use type hinting here to show that a is an integer, b is an integer, and the output of my function should also be a returned value of an integer. Okay. Okay, so how to call this function is I'm going to write the name of the function, and then for a and b, I'm going to assign these two values, which gives me 20 because 4 plus 2 times 8 is 20. Okay. And the other way is just to drop the names of these parameters, which works fine too, but it's better to provide the name of the parameters because it makes it more readable. Okay. Another example, let's say I have add numbers again, which simply add numbers and returns the value, but the values have default value. These parameters have default values. Okay. So if I call this function as is, it shows 15 because the default values are 7 and 8. The summation will be 15. Now, if I provide these two values, then I'm overriding those default values, right? So it gives me a 5. If I only provide a value for one of them, then it will only override that one. So if A is 2, then I'll get a 10. If B is 2, I'll get a 9, right? I'm just overriding one of them in these two examples. And if you only provide one value without any reference to which parameter it is, then it goes with the original order, right? So it puts a 2 for A, and then plus 8 is 10, right? So it's always a good practice to put the name of your variable. Is this A or is this B, to avoid confusion. And the last example here is, so actually I'm writing a function here, this function, find sum of digits, which finds the sum of digits that we had as an exercise in the previous example. So now I'm going to write this function so that I can try out multiple numbers without need any manual changes, right? So the function gets the number as an input, and it will return a string in the output. So the string is actually a report. The sum of the digits of the original value is this thing, the sum of digits that we're going to find right here. So it gets the original value, it copies the number into that value, and then sum of the digits, which starts from 0. And this is the same logic we use to find the last digit every single time. And then piling up to get that sum of digits. So when I run this, it shows that the sum of the digits of this number is 9. For the second number, we get 10. And then for the last one, we get 1. Okay. All right, so that was pretty much it for functions. Is there any question on functions? So I see there was a question which was answered by TA, that any runtime benefits of type hinting, and the answer is no. So this is not, there's no performance change when you use type hinting. It's just for the readability of the code, and for a reader to understand your code better. Also, if you're using AI coding assistance, when you provide these hintings, then it will be you will get much better predictions of your code. You'll see the difference if you use AI coding assistant. But yeah, that's pretty much it. There's no performance change. And then responding to the other, I see there's another thread. So is this enforced when you actually provide type hinting? The answer is no. So basically, it's up to the programmer to follow this rule that after you provide this hinting, it doesn't mean that the num has to be an integer inside the function. So it's up to the programmer to follow the best practices and make sure it's not going to change throughout the function. Any other questions? Abhinav, please go ahead.
Yeah, so I had typed this as part of my previous question as well, with regards to providing a hint and enforcing the hints. But wouldn't not enforcing the hints make it very difficult to support, like a collaborative enterprise level, application where, like it's very easy for me to break anyone's contract, for example, right? I mean, I can just change the underlying implementation without changing the definition, and everything breaks. So, are there code analysis tools, or how does this practically not cause major issues, the non-enforcement of things?
So you can actually. So this is not enforced, and I see your point. So you can actually insert assertion inside your code to make sure that there's an error. The user of the code faces an error if this hinting is not followed. But the type hinting on its own, it doesn't cause any errors or anything. So it will not enforce anything. So it's basically just you can think of it as a kind of a something like a comment or the something for readability aspect of the code. But yeah, I mean, you will find some of these kind of flexibilities in Python later as well that that could cause some of these doubts on the support on how different, if there are any pair programming or anything like that, what we can do for it. But think of type hinting as just as a hint, right? So that the other folks know that that this is the type of the data that we are using. But again, you can actually enforce that by including assertions, and we're going to learn about assertions on the third week when we learn about exceptions in Python.
Thank you.
Yeah, thank you. I see there's another hand raised. Jagadish, please go ahead.
One curious question: does Python have any ability to do pass by reference or pass by value, similar to
Yes.
C# or Java?
Yes, it does. It actually does it inherently, and we're going to see that as the last topic of the second week.
Okay.
For mutable objects, we're going to pass by a reference, and for immutable objects, we're going to pass by value. So let's wait for that until the last
Okay.
topic of
Got
the
it.
second.
Yeah.
Yeah.
Thank you.
There's a question that seems like Python and JavaScript are in the same boat with respect to typing. Great point. I'm not sure about JavaScript, but seems like they're similar in that case. Thanks, Milin, for the notes. And what will be the type of return if function returns nothing? It will be none. So if the function returns nothing, it will return a non-type. Okay, so we had the example right here, right? So if there is no returns for the function, then it will return none. Okay. All right. Actually, a follow-up question. None is null. Yeah, you can think of none as a null. So yeah, I mean, so null. So the difference is that null is defined for. I mean, the way null is defined is basically something that you can actually, it can correspond to all the data types that we learned. For example, if you have a string with no values, right? So if you define a string like this, then it's a null value, right? So we can call it a null string, but it is not a non-type in Python. So if you check the type of A, it's still a string, but the string is null, right? So the value is null. So that's the main difference. And later that we learn about NumPy, you'll see that np.null or numpy.null is a different data type than none. But you can think of none as a null value, right? Because null corresponds to so many different types. Yeah, cool. All right, so now let's go for another break. So we are done with the second part. We learned about conditional statements, for loops and while loops, and how to write a function in Python. In the last part of the class, we're going to learn about lists and strings. So we already know about strings. We're now going to learn about the special functions built in Python for strings. and we're going to see how similar they look like, both lists and strings, because they're both sequences of items. So let's take a 10-minute break, and then we'll be back to continue those two topics. All right. Welcome back. So this will be the last part of today's class, where we're gonna start learning about a bit more advanced data structures. We're gonna cover lists and strings in this class, and then we're gonna continue that next week by learning about tuples, sets, and dictionaries. All right, so let's first see what are lists. So lists are mutable, ordered collection of elements. So when we say mutable, we mean a data structure which can be changed after you create them. So you can change the size of a list after you create it, or you can change the value of different indexes when you create the list. So that in that sense, it is a mutable object. And it is also ordered collection of elements, because indexing is meaningful in a list. So each element comes with an index, and it is stored in a sequential manner. So that's why it's called an ordered collection. So in Python, lists are created using square brackets. This is also very important because, as you will see later, these are the main point of difference between how we create different data structures in Python. So if you change this square brackets to a parentheses, for example, then you'll get a tuple instead. Or if you have curly braces, then you'll get a set instead of a list. So here's how the syntax looks like. So we have these square brackets, these elements separated with commas. Here we have a list. If you want to get access to different elements of the list, starting from 0, you can get access to different elements by the value of their index. So some characteristics of a list in Python. So they're ordered, which means they maintain the order of the insertions. They're mutable, which means that you can change the elements in a list and you can modify it. A list is a heterogeneous data structure, which means that they can store elements of various data types. You can store integers as well as strings, as well as other lists or sets. So they're all allowed. They're dynamic, meaning that you can expand or shrink them automatically. And you're allowed to store duplicate elements in a list. Some basic operations for lists is accessing the elements by writing the name of the list and then the index. If you want to modify the elements, you can use this syntax with the new value assigned to the same index. If you want to get the length of the list, you can use the len function and then the name of the list. Concatenation of the lists is pretty similar to concatenation of strings. With the same order, you're going to get a combined returned list of combined elements. So an important note here is that this concatenation is going to return a new list. You can think of it as a function which will return a new list for you. Later, you'll see we have a function to extend a list in place without returning a new function. So this is a very important point. Concatenation in lists will return a new list. And then repetition of a list, if you want to concatenate a list with itself multiple times, then you can multiply it by some integer. Okay. Okay, so here's a list of most popular methods for Python lists. So the list is not comprehensive, but these are maybe the most widely used functions from list that we're gonna refer to here. We have append and extend to append items to a given list. So both of them are in place to change the current list. If you want to add, sorry, if you want to add items one by one as separate data points, you can use append. If you want to extend a list by another list, then you will use extend. Okay. You can insert an item at a specified index. You can remove an item from some given index. Another way to remove is pop. The difference is pop also returns the value that is removed. You can clear out the whole list. You can clear out all the items. If you want to get the index of some given value, you can find the index here. This gives you the first matched item. If you want to count a given value inside the list, for example, how many times number 2 is repeated, you can use this count function. You can sort the list, you can reverse the list, and you can also copy the list. Okay, so you can copy it on another list. How about iteration through a list? Because a list is a sequence of items, right? You can use a for loop to iterate through a list, similar to what we saw in the range, right? So you can think of the range of numbers as a list of items. We also have the concept of list comprehension, which is pretty similar to ternary operators, right? So if you remember, ternary operators was to write a conditional statement in one single line. For list comprehensions, you can think of it as a way to create a new list in one shot, in one single line. So here's the syntax. So you have these square brackets, the expression for item in some iterable given some condition. So I'm going to show you examples of this so that it makes more sense. Some use cases of lists, you can think of it as a dynamic data storage and data manipulation because it's mutable. You can change it. So you can think of it as a dynamic data storage. This is opposite to the tuples, which is static data storage because they're immutable and you cannot change them after you create them. So we'll see that later. If you want to implement data structures and algorithms, or so if there are data structures like stack, queue, or algorithms like sorting, searching, that you will see in the data structure and algorithms class, list is probably the best data structure to use because it provides many of the functions that are needed for these kind of implementations. Okay, so now let's see a few examples. All right, so let's define a new list. So here's I'm gonna call it my list, and this is the definition of the list with these values. So lists are heterogeneous, so you can actually have different values inside one single list. Now, let's say I'm going to get access to different values in the list. So I write the name of the list and then the index, right? So at index 0, I'm going to get 1. At index 1, I'm going to get 2, right? So it starts from 0. It's a 0 indexing way of calling the different values. At index 0 would be as the first element, and index 1 would be the second. If you want to get the last element, you can simply write length of the list and there will be -1 because we start from 0, right? So here we have 7 elements. If you want to get element 6, which is the last one, you go the length of the element, which is 7, -1 gives you the last element. Okay. Another way to get the last element is to use the index -1. So besides being a zero indexing language, Python is also a negative indexing language. So -1 as an index basically means the last element or the first element from the other side. Okay, so and then -2 is the second element from the right side. Okay, so we can go from the right side. And yeah, I mean, so if you want to get the first element from the right side, now instead of length -1, you simply have negative length because you have started from -1, right? And then we also learned that lists are mutable, which means they're changeable. So I can actually change the value of the first index or index 0 in my list to get this updated list. Okay. All right, so now let's see a few methods in Python for lists. And this is what makes this data structure special because of all the built-in methods that you don't have to implement from scratch, right? So one is the list concatenation. If you want to combine different lists, you can actually use this plus operator to concatenate them. So you know that this is reserved for arithmetic addition for integers, but for strings and lists, it's defined for concatenation. So when I run this cell, I'll get something like this. Okay. For multiplying a list, or basically concatenation with the same object multiple times, we can do this. Now, I'm going to show you other methods that we learned on the list in the slides. So let's see a few of them. So let's say I have a list of strings, right? And I'm going to add a new string to that. So you can use the name of the list dot append with the new data point, right? So and consider that this is an built-in function. So the object itself is changed now, right? So it's not returning a new object. It's a built-in operation. I can also extend my list with a set of new strings, right? So this would extend my list with another list. But note that the difference between append and extend is extend gets an input of a list, but append gets an input of just one single object. Okay. So if you want to add one single element using extend, it still has to be a list of one single element. Okay. Now, let's see a few methods to remove items. If you want to remove a given value, you can just provide the value and it will do that for the first occurrence of that value. So here, this is the first place that cherry occurs, then it will remove that. Okay. Now, the other way to remove items is pop. Pop is to remove items at a given index. If no index is provided, then pop will remove from the end. Okay. So the other difference between remove and pop is that actually you can get the value of the removed item returned. Okay, so you can actually pop the last element and then collect that value, and you can keep that value. Okay, so you cannot do that with remove. Remove does not return anything. But pop can also get an index. So if you get an index of 2, it will remove the item as index 2, but also you can actually select that removed element. Yeah. All right. You can get the index of a given value. So let's say our value is this string right here. So we can get the index of that. And yeah, so that is the first occurrence of that value, right? Now I'm gonna see how I can use count. So let's say I'm gonna count the number of times this string apple is recurring in this list. So I'm gonna add one more apple so that count shows me more than one, and you'll see that is now 2 because I have one here and one here. So I have 2 of that object. So it's gonna give me 2. Now I'm gonna just clear out my whole list. So I don't need that anymore. So I'm gonna clear all the items out. I can use .clear to do that. The next example is a numeric example. So let's say I have a list of integers. I'm gonna sort it. So I can use .sort to sort this list in place. Sort it from lower to higher values. You can do lots of other settings, how you want to sort it, and if you want to sort it descending or ascending, you can do all that. But custom sorting is something we're going to learn in full detail on week 3, beside reversing, right? So you can also reverse the list. But let's actually wait for that until the 3rd week. Another way to remove items is to use delete. And delete is the nice thing about that is you can actually have a subset of elements or a slice of elements for that to delete. So we're gonna actually see slice. Oh, actually, I think I jumped over slicing for some reason. So let me go back here. I'm not sure if we covered slicing, but slicing is basically extracting a subset of elements, right? So from the original list, you want to get a subset of the elements starting from the start index until the end index, which is also exclusive. So a start is inclusive, end is exclusive, with a given step size, right? So this is similar to range. But in this way, now you get a subset of elements from your original list, right? So by default, if you don't provide any start index, it will give you a 0, which means the beginning of the list. For end, if you don't provide anything, it will go until the end of the list. And for step size, if you don't provide anything for that, by default, it takes a step size of 1, which means go over all the elements in this range. Okay, now this is basically a slice of this original, of this set of numbers from 1 to 2, right? So 1, 2, and 3 is exclusive, so it's not counted. So we can actually remove 1 and 2 to get a list like this. Okay, and then the last thing is copying a list. So if you use .copy for a list, it will give you a shallow copy of the list. We also have a deep copy in Python. You can use the copy module in Python if you want to import it. So modules we're gonna also talk about later in the course. But so the main difference between these two is again something a bit nuanced. So when you do a deep copy, you get a totally independent basically variable. So when you get a deep copy nums3, it's totally independent of nums. So if you make any changes to nums3, you won't see any changes to nums. But if you do a shallow copy, then for the mutable objects inside this this list, then any change to nums2 will also change nums1 for those mutable objects. So the reason to that is probably, again, memory efficiencies. If you have huge data sets, Sometimes you want to have a centralized copy, and any change to that centralized copy is going to actually affect all the shadows or the copied versions. But if you want a totally independent copy, which in which case you don't care about memory efficiency, you just want to have two independent entities, then you use deep copy for that. So take a look at this link on the notebook if you're interested in this topic, and you can learn more about it. But that's not something to worry about for now. And we're going to use the shallow copy for it for now, because that's perfectly fine in our use cases. And then the next thing is iteration through lists. So let's say we have this list again. We can. So I think there was a question on this one earlier in the class that what are the different ways to iterate through a list? We can iterate through the values directly. We can iterate through the indexes, and we can iterate through both at the same time. So for iteration through the values, we can use for num in nums, and then print each item. So we are actually iterating through the values of this list, and each time we are printing the value. Okay. You can iterate through indexes, right? So you can get the length of this list and the range of that length. So here we have 4 values. The length would be 4, and the range will go from 0 to 3. And then each time we get the index, and now we can get both index and the value at that index. Right? Now, there's another way which you can actually get access to both index and value without any need to actually get access to that value at that index. And that's the enumerate function. So enumerate is a function in Python that bundles together the index and the value at that index for a given iterable. So in this case, a list. So we have this for loop. There's a tuple unpacking happening here. We still don't know about tuple unpacking. We're going to learn that later. But we're going to get both the index and the value at that index, which gives us something similar to what we had in the previous example. Okay? So enumerate gives us a bundle of index and values together at the same time. So we can check the existence of some given value in the list. So let's say I'm going to check if 10 is in the list. So I can simply check 10 in nums. It's going to give me a Boolean. In this case, it gives me a true because 10 exists in those values. But is 5 also in nums? The answer is false because 5 is not one of the elements of that list. Okay. All right, a couple more examples here. So list comprehension is another way of defining the list in in one single line. So I have these square brackets, which mean that I am defining a list, and inside the bracket, I'm actually lining up all the x's that I have, which comes from this for loop, and with the expression of powering with 2, I mean squaring those, right? So that value powered by 2. But what are the x elements that I'm going to line up here? They're squares. These are the x values, right? So for x in range 5 or 0 to 4, right? So what this is going to give us is a list of these values starting from 0, 0 to the power gives us a 16, right? So this is how the list looks like. Okay, so if you didn't want to use list comprehension, then you could use these 3 lines. You would initiate an empty squares, empty list, and then this for loop, you can use this for loop to append these elements one by one to get that list. Okay. Another example is, let's say from range of 10, from 0 to 9, I'm only going to get a list of even numbers. right? So I have a list X for X in range 10 if this condition holds. So this condition is filtering out the even numbers, right? All right. So the next concept is slicing. So I have several examples for slicing because I want to make sure that we see all examples here. So let's say my list is these set of numbers from 0 to 9. So if you want to slice through everything, maybe the default values are starting from 0, right? So my list start from 0, colon, go all the way to the end, the length of the list, and then with step size of 1. So this gives us all the elements in the list. Okay. So the other way to get all the elements in the list is to put nothing for these values, right? So we have 2 columns and nothing provided before or after. So this goes with the default values, which are these ones. So these are default values. Default values, right? So this would also gives us the same set of values. Now let's see some subset of values. So this is an example which starts from index 1. So if you go here, index 0, index 1, it starts from here all the way to index 5. So 1, 2, 3, 4, right? So this is going to give us a subset of those elements from 1 to 5. The next example is going to begin from index 4 and goes all the way to the end because nothing has been provided. And then by default, it means go with step size of 1 all the way to the end of the list. Okay. So the next example is going from the beginning of the list all the way to index 4 exclusive. So basically index 0, 1, 2, 3. Okay. The next example is starting from index 1, going all the way to 9 exclusive with step size of 2. So it's 1, 3, 5, 7, right? And the next one goes through all the elements in the list with step size of 2. So it starts from 0, and then we have 2, we have 4, 6, 8. Okay. So if you want to reverse the order, so you have 2 options. You could either use the reverse option that we learned earlier, or you can actually do this. You can say, go with the current order from the beginning to the end, but in backward step, right? So you have -1 backwards, which will reverse the values for us. Okay, so this is another way of reversing a given sequence. So you can do that using negative indexing, starting from -2 to -5 in reverse order will give you 8, 7, 6 because so -2 is 8, right? So going all the way to -5 is what? Is 8, 7, 6 backwards, right? So we are going backwards. Okay, so that is that. And then if you want to go start from -3 and then all the way to the end of the list, you can do that. And then going from -5 to -2, again, same thing, starting from -5 index and then going all the way to -2, but this will be exclusive, right? All right, so actually I put all these examples. You can take a look at them later as well. I wanted for you to actually have a comprehensive list of all sorts of examples. Okay, so going back to our slides, we have a couple class activity which I'm gonna pass. As I mentioned, usually we don't get enough time for these lead code problems, but I put them here for your own exercise. So now you know which questions you're able to answer. And we're gonna cover these questions and some other similar questions in class on Thursday. But before I go to the next topic, I want to make sure that everything is clear so far and there are no other questions. I don't see any questions on the Q&A. I think they're all answered. I see there's a hand raised. Vijita, please go ahead.
So in the slicing, is the second index always exclusive?
Yes, it is. So if you go back right here, so the start index is always inclusive. The second one, end, is exclusive. So it always starts from here and goes one before the end.
Okay. So a lot of times when we use so for the iteration, we always use is the for preferred approach to do iteration over lists compared to a while loop.
I mean, for loops are for a sequence, right? So if you have a sequence of items, then usually if you want to go through all those elements, then usually a for loop is a better approach. Otherwise, you have to, if you want to use a while loop, then you have to take care of the increments on your own.
Yeah, the reason I'm asking with the increments with this, with the negative indexing, it can get tricky, right? Because if we, in very traditional sense, if we don't use for loop and we write it with a while loop, we could do index. Let's say we're going descending order, we're doing index -1 and accessing the element. But in this case, if it becomes negative, we basically go back to the end, correct?
That's right. But even in for loop, I mean, you can do both in both for loop and while loop, right? So even for loop, you can have a reverse order and iterate in a reverse direction, or you can use a while loop and start from the end and decrement by 1, right? If you want to go backwards. So you have all the options in both of them. You just need to see the code to make sure that it's not confusing, but you have all the options.
Okay. All right. Thank you.
Yeah. Thank you for the question. I see there are more questions. Abhinav, please go ahead.
Yes, just wanted to double check one thing on the inclusion slash exclusion of the index.
Yes.
As an industry standard, I have seen that the use of a square bracket versus a small bracket, like the curved bracket, is used usually, like at least in package management and other, like versioning theories or versioning solutions, as including a certain particular index or including a certain version or excluding one. Is there nothing else like that in Python, or is it simply that this is, whenever you start, it includes the index, and when you end, it excludes the index? Does the question make sense, first of all?
So I'm not sure about. So I understand the question, but I'm not sure about the differences between square brackets and other notions, other symbols for collection of items. But in Python, I mean in the regular Python coding, usually when you see a range, then for example we had this range function. So usually the first item is always inclusive and last item is always exclusive, right? So that's also the case for slicing for lists or other iterables. I don't want to, so there's some minor differences with some other data types later that we'll see, but I didn't want to really make this look confusing. But later that we learn about NumPy, then you'll see that some of the range functions there would violate this rule. They're not exclusive at the end. So usually what I suggest in those cases is you always try them before using them. Just a quick try. If it's not easy to memorize, then probably a quick check would help. But sometimes in those functions like random generator functions, you'll see that this exclusion is basically not there, right? So yeah, I would say let's keep in mind that it's always an inclusive start and exclusive end, but it could be violated in some cases in some libraries. So let's see them when they come. So for now, let's not get confused with that.
Awesome. Thank you.
Thank you, Abhinav. And then I see there are more questions. Sukriti, please go ahead.
Yeah, so in the shallow copy example, is it like same as assignment x equals to I, or is it like there are some differences?
Let me go to so can you repeat the question? So is it similar to x is equal to I?
Yeah.
Did you mention?
Yeah, so is it like in line 195, is this same as nums 2 equals to nums, the shallow copy, or is there any difference? Like if we write nums 2 equals to nums, so does that do the
Oh, I
same
see
thing?
what you're. So I think it's pretty much the same. I think it's just the fact that. So let's actually check something together now. I'm a little bit, I doubt about this. So let's actually run this thing and then check the IDs, right? So let's check ID of nums and ID of nums2. So these are showing different IDs, right? So when you get a copy, basically saying that these are at two different references. But now let's actually try nums2 is equal to nums, and then get these two printed. Actually, let's do nums4, and then do nums4 here. Okay, so now you see that the IDs are the same, right? So basically, when you're doing this, my assumption is that any change, because it's a mutable object, any change to each of them will change the other one as well. So actually, I'm gonna try it right now. This is a really important point, and actually, we're gonna see that when we see num calling by reference later. So what is nums? So this is nums, right? And this is nums4. So if I append a value, let's say 5 to nums, then nums would be this, and nums4 would be the same thing, right? So if you make any change to nums, then the other copied version, so this is basically an assignment by reference, right? So the other one would also change. And I think this is the main point of confusion, that why don't we have the same thing for integers that we have in the beginning of the class? But I think now this should make sense, because we have two mutable objects at this reference, and a change to either of them will change the other, right? But now let's see what happens in copy. So you have nums.copy. So we have, let's do that again. So because we added 5 to nums, now we have nums2. And if I have nums.append, let's say I add another number 10, right? So now nums has a 10 at the end. And if I print nums2, it doesn't have that 10 at the end, because copy would also give you a semi-independent object. It only changes the mutable objects inside this list, right? So it's almost independent, but if you have another mutable object inside nums, and if you make any change to that, then nums2 will see that change inside that particular mutable object. Okay, so that's the difference. So hopefully this is clear, but let's just keep it there for now. Does that answer your question, Sukriti?
Yes, yeah, thank you so much. Yeah, I think that makes sense.
Thank you for the question. Vijita, you have a follow-up?
I have a follow-up to this question. So when you were explaining the difference between shallow copy and deep copy, I was thinking that shallow copy would basically, if we printed this nums2 here, would show a 10 at the end. because it was a shallow copy mentioned that it is not creating an independent object, but it seems to be contradictory of that. It seems like I didn't understand when you said it's partially independent, and from there on you mentioned something inside something that is mutable. Can you go over that one more time?
Yeah. So sure. Let's do that. So I think your image of this copy, I think how you were thinking of it was this way, right? So you were basically thinking that now they have the similar IDs, the similar identities, and now change to one of them will change the other one. Okay, so that's not the case with copy. So when you copy them, so let's forget about deep copy for now. When you copy them, then if you make a change to nums or nums2, it's not going to change the other one. So let's think of it that way. Okay, so that's the difference between assigning this assignment, which makes the IDs exactly the same, versus copy, which where we have two different IDs, right? And a change to one is not going to change the other one. So this is the difference. Now we have another concept called deep copy, which actually provides a totally independent object. So if I create this nums3, for example, now if I print the IDs, they're also different, right? So what is the difference between deep copy and shallow copy? And this is way beyond the scope, but the difference is very nuanced. So the difference is if you have a list of lists, right? So let's say nums is I don't know, 1, 2, 3, and then 4, 5, 6. So usually you see that people define matrices as a list of lists, right? This is very common, right? Now let's say, so let's do this. Actually, let's try this out. I have nums, and then I'm gonna make a copy of that. Nums3 would be the same, right? Like this. Now if I append nums by, let's say, some value on, and now nums is this thing, what happens to nums3? Nothing, right? Now let's see what happens if I add to the first element of nums. I'm going to append a 10. So this 10 is added here. Now what happens to nums3? Maybe I'm getting, yeah. So it's not added here, right? So because we have an independent deep copy. But if you try the same example on the copy version, you'll see that this 10 would be added, right? So this is the main difference.
Okay.
Does that make sense?
Yeah.
Okay. Yeah. Thank you, Vijita.
Thank you.
Okay, so is this session until 2 p.m. Pacific? Yeah, it should be ended by 2 p.m. So we have one more topic. I'm try to address all the questions, but the class is usually these classes take about 4 to 5 hours. So I signed in Discord, but I don't see any activity, any update on how to use it. So any questions about Discord or resources, those kind of things, if you can ask the operations team, that will be great, because I don't have much information about that. Can we do and check ID of nums? Okay, so I think we answered that. Are we fully in Q&A mode now, or are there any additional topics? So we have one more topic to go, which I'm gonna now cover to make sure we are not running more out of time. Okay, so the last topic is strings. It would be a little bit faster because it's pretty similar to lists, and you'll see why. So The only difference here, so first of all, strings are different in nature because they're used for textual data. They're also immutable sequence of characters. After you create a string, you cannot make any changes to that. You can use that string to create another string, a new string, but you cannot make any changes to that string that you created. So it represents text data and provides methods for string manipulation. And the way to define it, we have already seen that. You can use single quotes, double quotes. You can also use triple single quotes or triple double quotes. And the way you access elements for a string is pretty similar to the way we did it for lists, right? So here are some basic operations. You can get access to any index's value in the sequence of characters in a string. You can concatenate two strings to get a new string. You can duplicate a string or repeat it multiple times, get the length of string. We have a particular set of methods for strings. We're going to see that on the next slide. And then slicing works the same for strings as well. So here's a list of methods for Python string. Again, this is not a comprehensive list. There are tons of methods for strings in Python. These are some of the more commonly used ones, but we have more. So we can uppercase or lowercase a given string. We can partition a string around a given character. We can replace a part of the substring, a part of the string with another substring. We can find a character, the index of a given substring, so where that substring lives. We can strip the string from both sides, right or left, or both. We can split a string. So we can, for example, split all the words in a sentence using the white space in between them. We can check if a string starts with a particular character or a substring. We can check to see if the characters are digits or numeric. And we can also check the index of a substring. So find and index do the same thing. The difference is if that substring doesn't exist, find returns -1, but index returns an error. So it actually results in an error. Okay, so let's see some examples here. Okay, so very quickly going over that. So here's how we defined a string. You've already seen that. If you want to get access to index 0, index 1, or index -1 at the end, you can get those characters from this string. We mentioned that strings are immutable. So after you create a string, you cannot make any changes. So if I try to make any changes, I say I will get the type error saying that string object does not support item assignment. Okay. But you can use a string which you already created. Then you can actually concatenate it with another string to get a new string. Okay. So yeah, string concatenation works. Now, some methods that I mentioned on the slide. So you can get the length of a string using the len function, like for lists. Now, if you have a bunch of words, so let's say I have this string which contains 2 words, I can uppercase all the words, or I can lowercase using upper or lower methods. I can capitalize the words, which means that it only capitalizes the first word, or I can turn it into a title, which capitalizes all the independent words. I can partition a string by actually, if you should provide a character here, and it will partition that for you around that character. Here I have an empty character here. It will partition that into 3 elements for me. And this is a tuple, right? So when you see these parentheses, it means that it's giving us a tuple. You can partition around the first occurrence of t. So it's the first occurrence of t right here. You will partition our string over that t. You can split the words. We have 2 words, and you can split this sentence based on its words. It gives you a list of all the words in this string. Okay. Or you can actually split around a given character, right? So I can split around interview, around T, and you see that it will remove T and split it before and after. And you can actually specify how many times you want the split to happen. You can replace a part of the string. So instead of kickstart, I can actually replace it with ready, right? And then you can also do the opposite. If you have a list of words, you can actually join them. So you have a list of words here. You can join them with a space in between, or you can join them with a comma in between, right? So space.join gives us this, comma.join gives us this kind of join. Okay. Okay, so let's go back to the same set of words that we have in the string. You can find the first character that this substring occurs at. So it's 0 because it starts from the beginning. If I want to find something which doesn't exist, it will show a -1. Okay. The index for interview, it's again 0. So find an index, do the same thing. But when the substring doesn't exist, index would throw an error, right? So find would give us a -1, but index will give us a value error. Okay. More examples here. If you have a string with white spaces on both sides, using strip will remove all the white spaces on both sides. If you want to strip from one side, you can use L strip or R strip. So R would remove from the right side, and L would remove from the left side. Okay, so you can do all that. Do you want to check that the string is starting from a particular substring? Then you can use the start with. So text.start with Python gives us a true because the text starts with Python, but it doesn't start with Python is, so it gives us a false. You can check if a string is giving all numeric values. If that's the case, true, otherwise false, because there's an A here. Alphanumeric means alphabet and numeric both. So first one is true, but second one has a special character, so it gives us a false. You can only check alphabetic. And then slicing is also there for strings. You can slice exactly the same way as we did for lists. Some note here for you. If you're interested, you can take a look. And then a couple other lead code problems, reverse word in a string, and also find pivot index. Try it out. And then if you have any questions, let's go over that in the class on Thursday. If you're interested in more advanced topics, some more topics that you can go over, I've put some links here. It's not mandatory, it's just FYI and optional. So with that, actually we covered all the topics for this class. I mean, going over the agenda before I go to the Q&A for the rest of the class. But we covered some basics in today's class, and then learned about variables, data types, typecasting, the arithmetic logical comparison operators. Later, we also learned about ternary operators. Then on the second part, we learned how to write an if and else statements, loops in Python, and how to define a new function. And then last part, we started learning about more advanced data structures, which are lists and strings, and how their built-in functions work. So in the next class, we're going to learn about other data structures and also some other techniques in Python, as well as the scope of variables and calling by value versus calling by reference. Okay, so actually, I'm going to stop here. And first of all, thank you for attending the class. Hopefully, this was helpful for you. And we're going to continue with the same list of topics that I mentioned in next class. So please go over the assignment, review problems, and come to the class on Thursday with questions, and we can discuss things further. So I'm gonna stay here for a few more minutes, and let me know if you have any questions. Thank you all. All right. Okay, so I see a comment that class should have ended by 1 p.m. That was the schedule shows. Yes, I mean, the schedule shows that the class is 4 hours, but it usually takes 4 to 5 hours, as I mentioned in the beginning of the class. And the reason is I don't want to continue the class if there are any questions left after each topic. I want to make sure all questions are addressed. So the thing is that this class is recorded. If anyone needs to drop, I totally understand, and I apologize because there's no way I can, keep the balance. So feel free to drop if you have to, and then catch up with the recording after the class. So okay, so next question. Let me actually go over these questions one by one. All right. So I see there's a hand raised. Vijita, please go ahead.
I have my question in Q&A also, but my question is, for methods like replace or trim, are they returning a new string? Because we are saying strings are immutable. So are they returning a new string, or is it, because I
understand. I understand your question. So that's a very good point. And so it depends method by method. Most of the methods in lists are in place methods, so that you will change the list in place because lists are mutable. But for strings, it's not the case because you cannot change a string, right? So it is immutable object. So all of these methods are actually creating a new string because you cannot change the original string.
Okay.
Yeah, so basically what you can do is you can write new words and assign these uppercase words to that. So it's actually returning a new string that you can actually collect.
Yeah. Thank you.
Cool. So let's go to the next one. So I see Brian, you have your hand raised. Please go ahead.
Yeah, please, my question, sorry, my question will not be on the this. My question will be on the to install the Python, because for I have a Windows. When I try installing it, when I want to continue to run it, it keeps telling me an error occur. So I'm unable to install the Python on my machine. I don't know what might be the issue following the steps.
So you're on a Windows machine, and then which platform are you using to for Python? Are you installing Python with a package, or just the original the Python website?
From the Python website, I'll try to install it on my laptop.
Okay, so and you follow the instructions, and it doesn't work?
Yeah, it doesn't permit me to install.
Okay, so let me see if I can find a good link for you. So this is what I'm gonna do. I'm gonna actually search for a good link for steps, or actually maybe a good YouTube video for you to follow the steps. I'm gonna put that link on this notebook which I shared. I'm gonna update this notebook after the class on the same link, right? So you follow those steps. If it doesn't work, then connect with the operations and ask for a one-on-one, so that someone can actually work with you. You can share your screen and someone can work with you to install Python. So how does that sound?
Okay. Thank you.
So let me make sure. I'm gonna write a note on that. All right. So let's go over Okay, so I see also other folks need help installing Python. So let me do this. I'm gonna provide the steps for you. And then if that didn't work, let the operations know. Probably they can connect you with someone from help desk or some of the instructors like myself, and then you can go with a step-by-step guideline with a 1 hour one-on-one session, something like that. Okay. Other questions. Is there a mutable string type available like string builder in C# and possibly Java? Yeah, that's an interesting question. I haven't seen that, but I can double check. But I've never seen a string type of data structure. I mean, for sure, I know that the string in Python is not like that, but you're mentioning string builder in C# is actually mutable, which I had no idea. So I'm gonna check to see if we do have that in Python, but I have never heard of it. So I will double check that. Next question, from where I can find the steps for Python code on Visual Studio. So this is something I'm gonna share. Actually, there was a question in class today that how can I use Python on VS Code. So that's another link I wanted to share on the notebook as well. Installing Python, I think we mentioned that already. If I need to update, say, third element of the string, I know it is not possible, but you said we can make a new string with the same name. So it copies the old string in new memory location with the change in third element, deletes the old string, assigned to the old name to the new string. So as you see, just to change one element, we're doing so many things. Highly inefficient. Definitely not zero cost. So what is another option? Or build one ourselves, or use a list instead of a string. So that's a good point. So things go by design, and by design, a string is immutable. So basically, we don't have that option. One thing you can do, if you really need to change the third character without too much hassle there, one thing you can do is, let's say you have a string. Let's say it is ABC 1, 2, 3, right? Something like that. And then you're going to typecast it into a list, right? So we learned about explicit typecasting, and let's call this my list, and this is my list, right? So when you typecast it as a list, then because you have this sequence of items, you get each item here separated into a list, right? So now your sequence becomes a list. Now what you can do, because list is a mutable set, right? So now list is mutable. That's nice thing about list. It's dynamic. So you can have my list at element, let's say 2, which is the third element. I'm gonna change it to I don't know, uppercase C, capital C. And now the list becomes like this, right? So now you have to change your list in this way. Now we learned about the join, right? So now you have the option to join all these elements, like dot join my list, to get this string back, right? So join is the opposite of split in Python strings. So basically, after you get this list, you can now join them back into a string using this join, and this is how we can separate them. So if you want this space between them, you can do that. But because I want it to be a coherent string like it was before, I can do this. So you can actually write your own function. But the other way to do this is to get this string. So this was my string, right? So you can get this string and then create a new string by taking, as you mentioned, right? So by taking from 0 to 2, So I'm going to get letters from 0 to 2, which is A and B, plus whatever you want change you want to make, and then concatenate it with my string from 3 and on, right? So basically changing only the second character. So this is going to give me the same result. Okay, so basically you get the string, you blow it up, you get 2 slices from it, and this is totally fine because you're not making any change to the original string. You're just getting a blow up of the string, slices of a string, and then concatenate different parts. And this is more common actually. I have seen this more in different applications than splitting, typecasting, and then joining, because this is one shot, right? But both of these are ways you can do that. I'm not sure if this answers the previous question on string builder. I'm not sure if we do have a string builder in Python. I'm going to check that, but I hope that this answers the question here. Any other questions? All right. So I don't see any questions or any comments in the chat and Q&A. I also don't see any hands raised. So if that's the case and there are no more questions, then thank you all again for joining the class, and see you all on the Thursday session. Okay. Have a nice rest of your Sunday.